Hello guys, good evening, and I think we must be live now. I'm just gonna wait for the feedback and gonna do the audio checks as usual. Hopefully the music isn't too loud. In fact, I think it's a little bit too quiet, right? So let's see, this is a little bit better now. So testing 1 2 3, testing 1 2 3. This is how I usually talk. Now let's see how it sounds. We must be live now. This is how I usually talk. Now let's see how it sounds. We must be live. Now let's see how it sounds. We must be live now. This is let's see how it sounds. We must be live. This is how I usually hopefully yeah, okay, I mean music doesn't seem too bad. Yeah, so welcome to another day of doing some more C++. I am kind of missing other languages, I am not gonna lie. Written any Rust in maybe like a month's time now, so it's been it's been quite a while. So perhaps in the next stream we'll actually switch up a little bit. But I'm going off the recent kind of viral video that we had in the first stream. Let me just close everything here because we don't want to share all my friends here on Steam with you guys. But yeah, hello Robin, how's it going, dude? It's good to see you, man. Very good to see you. Yeah, I think the first video of this series has been quite popular. Like, it got literally 700 views in the last 2 days. So I'm gonna keep doing some more of this until we completely exhaust YouTube's algorithm. So good to see you too. Yeah, thank you, man. Thank you. But yeah, let's do this. So what did we do in the last stream? I don't know. Well, I do know. We basically supported a few more instructions in the program. So we have this very basic program here, which we were kind of running. So hex dump. Let's actually look at the history, shall we? And grep through hex dump, because I can't remember exactly which program it was. It was this one here. Pixel drawing. So we're just loading this program up and basically adding support for, you know, each instruction that we don't yet have support for. And I think the last one we got to was about, I think it was C8, right? So again, we're just going to be doing some more of that. Yeah, so, you know, by the end of all of this, hopefully we'll get to the end today. This program, if it works fine, it should draw a pixel or a different pixel for every possible pixel on my screen, right? So in other words, we're going to be actually drawing up the whole screen through the assembly code in today's video, which is quite interesting. And as we go along, I also want to write some more unit tests. So yeah, let's get started, shall we? Yeah, so we had a bunch of problems with Conan. I had some issues compiling SDL2. All those issues were fixed last stream, and I also pushed fixes to the Conan repository, and things are going well. I think it's going to probably get merged in the next couple of days. I think there's one particular pipeline that wasn't quite running, but I'll fix that maybe tomorrow or today. And yeah, let's get started. So last time, what did we add? So if we go into the emulator CPP, we added a bunch of other instructions here. One of them, for example, was 8a, which was transfer x to a, right? But we don't really have any kind of unit tests for this yet, right? So let's see if we can write some unit tests for this particular function. Yeah, so let's do that. So we go into tests. We already have here a bunch of tests, as you can probably tell. So let's just keep adding them here, right? So we have, I'm just gonna copy and paste the tests. In fact, why is it red? Oh, yeah, I've been very disappointed with the VS Code C++ LSP. It's been very, very bad whenever you work with modules. I'm not sure if you guys get that as well. I think Robin, you mentioned that last time. Well, you mentioned the last stream that you also have this problem, right? I'm not entirely sure when they will fix it, because you know, modules are here to stay, so they should probably get to this very shortly, in my opinion. but you know, nothing works with modules yet, and it's kind of annoying. Yeah. Let's add a new line here. What's the first test that we can do? Well, we have emulator tests, and we can transfer x to a test emulator emulates txa. Right, let's add some tests here. So we have the program here. What we can actually do is we can have some programs instead of just one. So std vector and we can have a few different programs that will do txa, right? So txa, if I'm not mistaken, which one was it? So we're looking at this particular instruction, so it's 8a. So we want to add AA here, right? And AA here as well, eventually, and 8A here. Now this function really only takes one no suitable conversion from one. Okay, I'm going to assume that this is fine, and it's just LSB issues. So this function doesn't take any bytes, so it should really be the only one. But before we can test this one, we actually have to load something into the accumulator, or into X, so we can then transfer to accumulator, right? So let's also call that in the first place. So we have load into X, LDX somewhere, I believe, right? So this is LDA. This is not right, this is break. That comment was wrong. So we're going to use the instructions to load into X, load into X first, to load the value into X, and then we're going to make sure that by running txa, we're going to end up with the same value in the A register, right? That's it. That's all that we do. And I think txa doesn't actually set any flags, if I'm not mistaken. We can find that out now. So let's look at the 6502 instruction set, and then just make sure that we are correct in this assumption, txa. We have this here, and it doesn't set. Oh, it does. It does set some flags here, so we have to test the flags as well and make sure that they do change, right? So yeah, let's do that. txa, and we're going to use A2 here with the byte. So this is the immediate A2 first. So 0x_A2. We're going to put the first value, let's say, is 01, right? And then txa at the end. This is the program. So, hello, Antonio Jr. Welcome to the stream. Bem-vindo, meu amigo. So, Antonio Jr. is a different Antonio to the one I've been talking to on Discord, I think, right? I know you guys made me confused last time because I think in one of the streams there were literally like 3 Antonios, and I was like, oh, which Antonio is this? So I'm gonna just confirm here. Yo, amigo, hope I'm not banned because of last time on Powerline. No, you're not banned, dude. As long as you don't like, as long as you don't spam too much, you know, you're not gonna get a timeout. But I'm not gonna ban anyone. Don't worry about it. Unless you offend someone else in the chat, then you know I can't do anything about that. Just be a nice person and you won't get banned. Yeah. So. If you guys haven't done it yet, please like the video. It does really help to show to other followers and stuff. Otherwise the YouTube algorithm will not work for me. How do I get my DMs? Oh, there you go, there's a tab here. Yeah, Antonio Augusto is another one. So anyway, so yeah, this first program here, this will load 01 into accumulator. And then we will copy the value, the accumulator val, to, we'll load into X registry, and then we'll copy the X value to accumulator. This is what we expect this program to do, right? So yeah, let's do that. Emulate txa, no flags. We're going to have different tests here. This particular test is just to make sure that the value gets copied and nothing else. And then we can have some tests for the flags. So whenever we copy a 0 over, that should set the 0 flag, so the Z flag, for example. And whenever we copy a negative value, then we should make sure that the negative flag is also set, right? That's what we're going to be doing here. I'm going to copy this a few times, just make sure that the values are set properly. So 02 and then 03, and then A8 or something like that. Actually, we're using lowercase. Oh, can we copy FF? I think we do. Arkanaf, my favorite Giga chat. I think you're the guy who commented on that video, right? Yeah, thank you, dude. That made me giggle a little bit. But welcome to the stream, man. Welcome to the stream, man. It's nice meeting you, dude. So yeah, hope we can enjoy us doing some tests here. So we've got the programs that will essentially load values into the accumulator, into the X registry. I keep getting this wrong all the time. And then transfer it over to the accumulator. And then we just want to test in this Google test that things are kind of working the way we expect. So yeah. Avo Afonso Bispo. Hi, loving the streams. Been watching the VODs. Keep up the amazing work. Love from Portugal. Abraço. Muito obrigado, meu amigo. Thank you. I love getting people who actually speak Portuguese here because I can talk in my own language. But yeah, I try not to, by the way, because I know that there's hello. Now the thing is, mic is working, but the headset is not working. Wrong mic, yeah, of course. Terrible. Hello, now this should be a lot better. I have no idea what happened, and the thing is, my headset still wasn't working. I've got this shitty headset that keeps disconnecting all the time, and it's like a Bluetooth kind of like out of ear one, so it doesn't go in your ear. But yeah, yes, we are blessed once again with the timbre of your voice. Dude, you're making me blush here. Stop. Anyway, so I'm assuming that things are good, right? So it's probably me just like touching the wire and disconnecting it. But yeah, let's go. So yeah, for every program here, we're going to make sure that we end up with the right value in the A registry. That's what we're going to do. So what we do want to check is that A has the value of program at, I guess, 1, right? So 1 is always the one we want. We don't care too much about X here, and we don't care too much. Oh, we do care about X. X should also have the value of program 1. So A and X should have the same sort of values here. Y, we don't care about Y. And the PC counter should be a 0, 1, 2, right? So it should be, yeah, it should be a 2 again, right? Should be a 2 again. I believe it should be a 2. So let's leave that there. Yeah, and I think that's the test. That's exactly what we need for the test. So let's recompile this and see if things work fine. Please don't give me an error. Oh, it gave me an error. Right, so what was the issue? And this is where we have to like painfully read the C++ errors. So how many of you actually do C++, by the way? How many of you have any experience with C++? I know, Robin, you have a lot of it. But I do wonder like how many people watch me and have actually done any reasonable C++ in the past. and how much you hate the compiler errors. Oh yeah, no Coke Zero today. I wish I had some Coke Zero. So no viable conversion from int to stud unsigned characters. So 0, 2. Ah yes, that's because I have one less thing here. Now this should work. Excess elements, yeah, that's right. We should have 4, 5 here. A lot of it is a bit on the edge, CX, like the language. I just never done any large scale projects or production things with it. I had looked at it something like 20 years ago, dude. Yeah, that's a long time. Maybe you should relook at it. Pass an argument to program. Yeah, so the thing is, like, I do love C++ and I've done it for so long that I can just decode errors that make no sense. So for example, we were compiling this before, right? And this is something you don't get in other languages. So the issue here is that this bit of code doesn't compile, and all I'm doing here is I'm trying to define a stack array, essentially, of vectors, right? A stack of vectors. But the first error we get here, it just says no viable conversion from integer to vector. And this is the first one here. So you wonder, what is the actual issue here? So you can kind of feel like, you know, this bit of code isn't right. The first thing isn't actually quite right. What it doesn't tell you is that there's an easier way to solve this. Like what you should be using here in this particular case, in the shorthand case, is you should be using something called initializer lists. And for you to be able to use initializer lists, you just have to put an extra parenthesis here, and C++ will automatically sort of convert this to an initializer list, right? Which is something that like other languages like Rust, the Golang, can actually suggest to you, like a solution to it, because the compiler knows that this is the case. And as soon as you do that, this particular bit of code compiles fine. Now this one doesn't, and we'll get to that in a second. But this is the main issue that I have with C++, and the main issue that, you know, I guess new people will find as well. But yeah, it takes years and years of working in full-scale projects for you to be able to sort of map out the errors and what the solutions will be. So yeah, I'm in a position right now where I don't really struggle in interviews anymore. Whenever they sneakily put an error somewhere on purpose, that will give you a massive compiler error or something that is completely a red herring. So hopefully the thing I'm working on will now be the one. Yeah, Robin, if you have anything cool, man, I'm happy to contribute. So always make sure you let me know, and I'm happy to review it for you and give you some ideas and such. Now, getting on to the next error. So emulate a CPU program. No viable conversion. Yeah, so this is basically execute CPU and program. This is basically because this function takes a span, right? And a span is a C++ 17 struct, I think, which is essentially just a fat pointer to a vector, right? So you can see it here. And yeah, we can just convert that real quick. I guess what we actually do is, in this case, we can do the pointer itself, so program.data, and then program.size. And in fact, I do really think that this should really be a spam to a const. I think that's how you write a const bit of memory, but I'll take a look at that in a second. And this should work now, hopefully. Oh no, it doesn't. It really doesn't work. No matching constructor for initialization spam from unsigned character. Hopefully the thing, absolutely. Okay, didn't miss anything important. So let's look at this one. So error, no matching constructor for initialization of spam from spam of unsigned character. So what type is it again? So we have stud uint8, which should match program.data as well, which is uint8. So the types of the pointers are correct. Let's read a little bit. Template ignored, constraints not satisfied. Can you Can I ask you a question of development environment? What is stud spam? One question at a time. So Ivo, development environment. I'm actually running on WSL2 here. I just prefer to run Linux compilers because they tend to be a little bit nicer than MSVC errors, in my opinion. So I'm compiling here with Clang, I believe. So in essence, I'm running C++ compilers on WSL, and I'm running code within WSL as well. So I've got all the extensions needed here for C++. And if you just search for C++ on WSL, on the VS Code extensions, you have the same setup as me. What is stud spam? So stud spam is what we call a fat pointer. So a fat pointer, see if I can get it here. So a fat pointer is essentially just two things: the pointer to the data, and then the pointer to a size here. This is a fat pointer for you. Now let's cover that. So here we have the data pointer, and then here we have the size, which usually is a stud size 2 or something, right? So this is your fat pointer, and it just says this is a bit of memory here, and you know what type it is from the pointer itself, and you know how many data, how much memory you have in that type. So in other words, it's an array. It's an array, but a little bit lightweight to copy around. This is your spam for you. This is what stud spam is, right? This is what stud spam is. Okay. So in C, if you know C, I'm guessing you do, it's sort of analogous as kind of calling something like, you have your function here and you have your data, which is like say it's an integer data, and then an int for the size. Same thing as passing this here, right? Instead you have spam. And it's just like the modern C++ way of doing these things. I believe it does some sort of checks on bounds sometimes, I'm not sure. But yeah, I mean, it's what we should use nowadays, basically. But let's see what's going on here. Because it's compatible reference. Okay, we don't care about that. Okay, yeah, this is because, again, we have the program here as a spam of uint a. But program.data is actually a const pointer to a std8, right? So that's why it wasn't working there. And again, kind of interesting, but so next execute. So now we have to change the whole thing here because we misdefined it. It should be const anyway. That's what we're taking a const reference. Right, error matching function for stud. So we have the program. Right, so all these functions here will have to have a const there and a const here. A little bit annoying, but this is what we should have anyway. We're basically saying that the pointer that we want to get here should be constant. It shouldn't be any pointer that you can change the memory. So no pointer here, spam here, spam here. Let's just use the compiler here to be... There you go. So now the test compiles, and yeah, I'll read the text in a bit. So let's just run these things here. So if we run emulator tests, what do we have here? Does it not show the particular test that we have? What's the test discovery? Pretty sure that something will fail. Zero tests passed. How is that possible? How is that possible? So line 86 failed, and which one is it? It would be nice if we can like debug this particular one here. Right, reading the text, reading the chat. I frequently switch between Ubuntu and Windows since I dual boot. However, Linux faces compatibility issues with NVIDIA on boot. I'm curious about the development experience on Windows and WSL. I mean, I kind of like it, dude. I mean, I would love to have a full-on Linux machine here. In fact, the only reason I keep saying this on stream, right? The only reason why I haven't switched to Linux yet is, well, editing software. So I do a lot of video editing, and unfortunately, the one I use is Adobe Premiere Pro, which is only available for Windows. However, when I'm at work, when I do development on like Raspberry Pis and stuff, it's always on Linux. So I do much prefer Linux just because it tends to be an easier environment to set up. And you know, I do a lot of work on the cloud and stuff nowadays, which is just basically Linux as well. So spam, may I ask your age, Matt Chad? So yeah, sure. I mean, telling my age is not gonna cause anyone to find out where I live, right? But yeah, I'm 28, dude. Not as young as you may think. But when should you use spam versus array versus vector? 0% passed. Yeah. So Robin, good question. So the reason why I like to use spam, right? I like to use spam because it's very easy for you to convert many types into this type, right? So for example, you can have a stud vector, and you can have a stud array here. And if you're writing a function, for example, that's taken a vector, you can't pass that array to it. Just no way, right? However, if you're writing a spam, there's a very easy conversion that you have to do here to pass in, you know, both arrays and vectors to the spam. All you have to do is, as I said, pass into the constructor the data, where the data starts, which both vector and array have. They both have the .data function, and then the size of it, which is the size. So that's why you use spam in well, more than these two types, because essentially you can pass in any contiguous memory to a spam. Contiguous, I mean, you know, memories like vector, where all the bits are next to each other. So vector has that, array has that, and you know, there might be other types in the standard that do that as well. So that's why you use spam. Rabane, just started my Python journey. Was wondering if you had any tips. I've been working in IT for the past few years, ASAP network engineer, but looking to switch roles. Network engineer, dude. I don't really do much network engineering, to be honest. I mean, the very little experience I have with network engineering is just by setting up things at home, really. But I will say, like, if you just started up, just like pick up a project that you enjoy, whether it's Python, C++, Golang, and just really learn logic of programming. And alongside, because you're doing network engineering, I would say just learn the Linux system inside out. So learn all the commands that you can do, how you can like review network settings on Linux, on the terminal, how like the tools that people generally use and stuff, because that's really going to help you in the long run, right? Sorry, I meant as instead of ASAP. No worries. But yeah, learn those things, learn the basics, make sure you get them well. So for example, learn how to use Linux well, learn how, I don't know, like network cards, how they work and stuff. Learn basic like networking tools as well, like Wireshark is a really good one for you to understand what's happening when you, for example, when you connect to a website. It's very useful to kind of understand the process that's going on in the background. So like how handshaking works, you can see the packets being sent back and forth, you can see how you're exchanging keys and stuff. It's really useful for a network engineer to know like that basic sort of security stuff. So that's what I recommend. But as I said, I'm not a network engineer myself, so that's what I would do personally. You look much younger and you are quite knowledgeable for your age. Congrats on time well spent and what you clearly love doing. Thank you, Akona. Kind of guessing that you're in the business as well, right? You seem like you've been doing development for a long time, so it's good to hear that from someone who clearly has experience as well. Yeah, let's go. Now going back to the code, and I love chatting a lot, but let's continue doing this. So why did it say that 0 tests passed? Because this is really weird. One test failed out of 1. So interestingly, it didn't really find the other ones. It just found this one test. Or I guess it's only finding this. So it says 0 out of 1 pass because it's only running, well, it's running all the tests in the same suite of tests here. So even if one of them passes, it says that the whole thing, even if one of them fails, it says that the whole thing fails. That's fine. Let's debug it and see what happens though. Okay, so we don't care about this one. We know that this one passes, right? So immediate LDA, we don't care about that one. We know it passes as well, right? Yeah, so it passes everything so far. We know that this one passes too. We don't care about this one. Now TXA, this is the one that fails. So we're setting all the programs here. So we go into the same first program. You can see here that the values are the ones I set up here. So we can execute the program. Oh, we have an unsupported command. Huh. And what is that? That's why it fails. So what is the command that's unsupported? 132. 132. What is that? 132. 132 is 84. But 84 should be supported. Did I just mistype it here? I think I might have like made a typo here. So it caught a bug, which is good, right? We caught our first bug. I know I'm getting a lot of messages here, so I'll continue in a second. Yeah, instruction set. So TXA, the opcode is 8A, right? So 8A is the one. So TXA is 8A, and I think in the test I made an actual typo here. So instead of 84, it's 8A. Right, if we recompile this now, it should work as expected, hopefully. Sorry, Mentas, okay, do you have a Linux preference? Linux preference? Not really, to be honest. I mean, I tend to work on Ubuntu quite a lot, and that's just simply because it's the most popular distro out there. So like, most developers actually do work on Linux. And it just means that, you know, tools tend to be more supported for like Debian distributions and stuff, which means that you're gonna have like less issues with Ubuntu if you're doing development work and then you're using like an obscure tool that doesn't work in every distribution. There will surely be someone out there on the internet that had that same issue on Ubuntu Linux, which means you probably have, you know, easier ways to find fixes. That's why I use Ubuntu. However, I will say that I do like Arch Linux as well. So like whenever I have a very like low-powered system, such as, you know, I've been working on the Raspberry Pi quite a lot recently, doing my side projects and stuff. I like installing Manjaro on it. There is a very lightweight distribution of Manjaro that actually is quite nice, and it uses Wayland, and it's the one that's managed by. Well, let me just get it up here. I can't remember which one it is. It's the one that has a Windows sort of a window tiling system in it. So if you look at ARM, I like this one here, the Sway one. So this is like, if you love doing like no mouse work, so if you don't like your mouse at all, try this out on a low system or even on a VM. It should work fairly well. But yeah, it's very good. But as I said, you can't really do development on it because I found that it's very difficult to get things working properly on Manjaro. So as soon as you come up with an issue with like Docker or something like that, it's going to be very difficult to fix, and you'll be like hacking the kernel, which is not what you want to do if you want to get some quick development done. But those are my preferences, by the way. Of course, I like Windows as well. I can't say I like Windows. I work on it all the time. And, you know, when I do gaming and stuff, it always seems to be on Windows. Anyway, let's run this now. So we still have an unsupported. Oh yeah, this is the emulator app anyway. If you go to tests, one of them still failed. TXA no flags, and we can see what that is. All right. Oh shit, we don't give a shit about this one. We only care about this one. So we have 8A everywhere. So what actually does fail? So it does execute the thing entirely now. So the first program that we had is this one here that loads 1 into X and then transfers it to A. So we expect X and A to have the same value, right? So if we look into the register, we do have that. We have 1 and 1 in X, and then the PC counter is 3. So this, yeah, the only thing that is actually wrong here is the PC counter. So the PC counter, or the program counter, basically tells where in the program you're reading, right? So for example, when you start a program, it's going to be a 0. So it's going to be 0. PC counter is going to be initiated at 0, initialized at 0 all the time, unless you have a different piece in your memory here. And for that, let me bring up xCalidraw for you guys to understand what I'm talking about. So unless your program is like somewhere that's not in 0, so say it starts at 0200 in the 6502 CPU, your PC counter is going to be a 0, which is what we do here. That's the convention that we're using, right? So when it runs the entire program, you can expect the value of the PC to be 1 past the last value, which is 3, right? So it's what we have here. And again, if we build this and then compile it, so if we build this and then run this, we should see hopefully it working now. There you go. So everything works. And you can see the power of actually writing tests when you're developing something. And this is, very important for you guys who are learning how to code. Even if you don't believe in TDD, you can still like write your program and then write some tests for it straight away. Because if you don't do this, if you don't test your program, it's going to be wrong. And you can see here how many bugs I've written by just doing some very simple functions in 10 minutes. I wrote like 2 or 3 different bugs, and I only found them by actually running the program through a test. Either it's unit tests or, hard code, sort of like not hard code or hardcore testing your program on the command line and stuff. Always test it. Always test it is what I can suggest to you guys. And it's really annoying when you sort of review someone's work. Either, this is not necessarily my work, because, people do tend to test that stuff quite well at my place of work. But when someone raises a PR for one of my projects, for example, Urchin is a good example, and they've clearly not run the code that they've pushed, and nothing works when you run it, it's kind of annoying, really. So always test your program. Sorry, meant, okay, do you have a Linux preference? How long have you been a developer for, Rabani? When did you start? So I started, well, if you count non-professional development, so I actually started quite young, maybe like 12, 13, when I was very bored and had nothing to do in the UK. Because, yeah, it's an interesting story. I moved from Brazil to the UK in 2009, and I really didn't have much to do, so I spent a lot of time on the computer, basically, and that's how I started. Hello, Antonio Augusto, the second Antonio in today's stream. Bem-vindo, meu amigo. So it's been a long time. I mean, professionally, I've done, I think it's just over 6 years of programming now. This is like work out of university. I did have some work during university as well. I was like working for the university itself and like freelance work and stuff. So I'm not going to count that bit of work, but yeah, professionally 6 years with all this in mind. So, okay, so we're certain that this works, right? So TXA does work with no flags. Now, if we do check the flags, right? So let's see which flags we can set. Emulate TXA, 0 flag. So now let's do a program that should set the 0 flag, right? So for example, well, we can actually just remove this overall now. Ooh. And then we have that, none of this. So now this particular program here is going to load, going to load 0 into the X register. And then we're going to transfer that with this command to the accumulator. And we expect the 0 flag to be set, right? That's what we expect here. So let's do it. So we have the CPU, and then we don't need the for loop anymore. It's going to be a very simple test now. We're going to execute the program data. In fact, can we just do program here? I think the array should be implicitly converted to a spam. This is what Robin was asking before. I think some of these types in the standard are actually implicitly converted to spams, Robin, if you're still interested. So for example, array, this should compile. But yeah, we expect that to be 0 here, and we also expect some new flags, right? So we do assert equal, and then we CPU.flags. Now, which flag is it that we want? I can't remember very well. Yeah, the flags. This is what we expect. So whereas XTA no flags, XTA flags, this is kind of what we want. I'm going to check that the flags of the CPU is 0 in this case, right? Yeah, because all of these are 0. And then do we set with negative? Yeah, negative is the 0, 1, 0, okay. This is how we define this. And then there'll be another one here, again. Ooh. So the other test we want to do is like, we want to do a test flags when loading a negative value. Back to the chat. Do you have any qualifications? Do you recommend? Sorry for all the questions. Rabani, not really. If you want to, I mean, you can become a developer, dude, with no qualifications whatsoever, as long as you practice it, as long as you learn the basics of programming. I would recommend learning some maths as well, because it does really help, even though you don't really need it. It's helpful. But you can do all of that without going to university, without, you know, finishing. Well, you probably do have to finish school. First thing, you know, finish your school and your secondary education, because you're going to need that anyway for life. But you can just join like a boot camp and read a few books, and you can do that. Saying that, I did go to university. I did a computer science degree with mathematics. And aside from that, I don't really have any other qualifications. I mean, I'm trying to get some AWS qualifications in the next year, because it does help, you know, progressing into more kind of responsible roles, like maybe a software architect, maybe a team leader, something like that. But at the start, you don't really need any qualifications, man. That's cool. If you just have the interest and make your own projects because you want to, not because you, yeah, exactly, yeah. Let me read that again. I think I understand that. If you just have the interest and make your own projects because you want to, not because you need to. Yeah, exactly. That Robin says it good. So I've posted like a little short in the past where I basically say, you know, do it because you like it, not because you're looking for a job. So if you enjoy Rabani, just keep doing it, and one day, you know, you find a job quite easily once you understand things. But you gotta enjoy it, because if you don't enjoy it, you know, you're gonna get into programming, you're gonna find a job, and you're gonna hate it for like a few years, and then you're gonna quit anyway. So make sure that you enjoy it. That's what I'm trying to say. So 0 flag is set in this case, and then we have emulate CXA with 0 negative flag. So in this case here, we're gonna do something like F1, right? So F1, this value should be a negative value because it's, you know, in 2's complement. And those are for you guys who have done 2's complement before. I'm guessing, Robin, you probably have done this, right? So 2's complement, F1 is negative. And yeah, this should work fine. So we expect this to be 0, 0. And the very last flag here to be that. Let's build it and then test again. Okay, so all the tests pass, and we can be sure that TXA does work very well now, right? With that in mind, let's actually, you know, we've got all this sort of like app that will draw some pixels on the screen. So let's actually try and finish it by adding more support to it. So the way I'm doing here is like, I'm basically just loading this 6502 program that has some instructions that will draw to the screen, right? But we've not got all the instructions set here yet, and that's what we're going to be doing. We're going to be, you know, doing some more of those. So let's see the first one that we hit that we don't yet support, for example. So the first command we don't support is 200. So 200, what is 200 in this case? So if we see here 200, So CH is something we don't support. So let's look at CH and see what the opcode is. So CH right here, right? So CA, so that's increment index y by 1. Yeah, we can do this one. So we already have a function that increments. Okay, and it does set the stuff here. So this function is going to be a fairly general one because we can see that we have a few other instructions that kind of do the same thing. So these ones here. So let's implement this one for X and Y at the same time, right? So when I was a kid, I did projects for everything, like everything, because I love the idea of problem solving whilst my friends that thought I would just learn programming and earn money never made it. Yeah, that's exactly how it works, Robin. I've got the same experience as well. Every now and then I get someone coming to me and being like, you know, I want to do what you do, what do I need to do? And I tell them like, you just got to do it and practice, and you got to do it well for a year and a half until you learn shit. And they start doing it, but then they give up after like 2 or 3 months and they never make it. So it's just about, you know, doing it because you like it and being consistent at what you do. That's, you know, with that mentality, you're going to go really far in life, not just with programming, with everything. So let's implement that. Let's implement this function. So increment. So what do we want to do? Let's see where TXA is here, increment 0 page. So let's probably put it next to this one because it kind of makes sense, right? So stud optional, stud size t, and we have increment increment. I guess just increment, right? Increment register. So we want the emulator CPU in here. And we also want, I guess, the register. So this is kind of what we want. Stud uint8 t. And we want an emulator registers. And then we have the reg here, right? Is this Zelda? Because it feels like it's a copyrighted song. I don't want to play it just in case. I feel like it might be. By the way, I'm using a new playlist, Robin, so thank you very much. Hopefully we'll have even less copyright strikes. Okay, so now we don't need to get a value here, so this is always going to be a return 1 in this case at the end of it. But we do need to do a CPU dot register dot reg, I think it was, right? Plus plus, simple as that. Okay, yeah, because this whole thing is like, yeah, that makes a little bit more sense now. And because we plus it could wrap it around, I guess. So which flags do we actually set on this one? Because it should set the carry flag, right, or something. So increment sets the negative and non-zero. So I'm surprised to know that this one does not do the overflow. Yeah, why does this not set the overflow flag? The V is the overflow flag in the register, in the CPU. So whenever a value wraps around, in theory, it should set this up here. So I would expect anything that increments any value to actually set this flag. Which is interesting. Let's see what happens in the other emulator, shall we? So we have the 65 emulator online. Now let's say we load into X here. Load into X the value FF, right? And then we do increment X after that, and then we do a break. Alright, so assemble it, code assembled, and then if we do a debugging, so we're going to step through FF here. So you can see that the flags yeah, so we step through, and then because we set an FF, that's a negative value, so this negative did get set. And then we do an increment X. So the 0 flag is set in this case, and 0 is unset. So yeah, it doesn't do the overflow. That's interesting though. That's very interesting indeed. Is this something that the increment function does? No. Yeah, that's interesting. I mean, incrementing the registry, incrementing the register is not going to set the overflow tag, so the overflow flag. Cool. So what do we want to do? We want to do a CPU.reg. Oh no, we want to do a flag, right? So CPU dot. Now we want, I guess, 7 here, right? Which is going to be equals to the CPU value, the registry itself. So CPU.reg. If this value is equals to or it matches, I guess. In other words, if the first bit here is 1, I think that's how you check it for negative values. I'm gonna... Hello Bobby, welcome to the stream. What do you mean Robin never made it? He made it, he's here. Robin is a very fine young man who is finishing his university and he's got a business already, so he made it more than anyone else here. Yeah, let me just make sure that the 6502 negative numbers is actually a 2's complement, right? So bytes in memory are just bytes. They're either signed or unsigned. The value of a byte can, however, be interpreted as signed number int 8 or unsigned number uint 8. The same for the value of 2 consecutive bytes, okay, and the value for consecutive bytes. To handle these bytes, you have several 6502 instructions that allow you to perform several operations for both signed and unsigned interpretations. You just have to use the right instruction and use the flags for what you need to. There you go. So it is 2's complement. The carry is used for multi-byte array. Those topics have been written about hundreds of times. There are 260. So yeah, so 2's complement. This is how it's stored. In other words, this is how we do the check for a negative number here. And we also have to check that the first flag or the second flag, which one is it? Yeah, the second flag is positive, right? So there's checking that the value is 0. Right, that's all. And then we return 1. And because of this, we can now eagerly add increment X and Y here. So C8 and E8, right? So C8 is going to be increment Y. Let's go to our little thing here. So C8 is definitely between these two. So K is 0x C8, and this is LDY. Sorry, in Y. Ooh, and then we want increment register, CPU, and then we pass in the emulator registers, and we want to do Y in this case here, and it has to be a pointer to this one, and this will be the bytes read, and then we can break. And you can probably tell that it's going to be kind of similar for the E8 instruction, which is the X one, same thing. So we're just going to put it up here. E8 is the one, so K is E8, 0x E8. So this is increment X. This is not what I wanted. And here we go. So that's why. Right, I know it's not making much sense for you guys now, but all that we're just doing here is like supporting more and more of these things here, right? So that's what we're doing. I can see that the next one that's going to fail is E0. So yeah, we're going to have to support that one next. But yeah, we should probably write tests for these, right? So let's write a test for this include registry. So make sure that we have the test for those. So increment, right? I'm going to copy that one. I'm going to put it here. Well, maybe we leave this to do because I'm not sure if it's done actually. But let's see, we emulate increment x, no flag here. And we have these programs, right? So what do we do here? So we can load x into, we can load the value into x, right? So let's see which one was the LDX here. LDX. So it's A2. A2 is the one, which, surprise, surprise, we've already got it here, right? What we are going to do is remove that one for now. And remove this one for now, because I think they're going to be possibly... Yeah, they're possibly going to be negative numbers. So let's just look into those ones. So for every program, we're going to execute it. And we're going to increment x, which one was it? C8, right? So C8 is the last one we have to do here. So C8, C8, and then C8 here. So we expect, we don't care about A registry anymore, so we expect this to be program 01 plus 1, right? That's what we've done, essentially. And PC counter is going to be 03, and we do expect all of those things. And stack pointer is going to be 0 as well. And yeah, I mean, that's it. That's the test for those. So it's very... Ooh, what do we do here? Warning. We have a warning. I guess we can kind of remove it though. So warning, and has lower precedence than the equals. What the hell? Ah, yeah. It should have just been this, I guess. I should probably turn all my warnings into errors, because I would have caught an error here. See, that's why you always turn warnings to errors when you can, because you might have weird code lying around. I wasn't assigning it before. You know, none of you caught up the errors, so like, what are you guys doing? By the way, what's everyone working on right now? So I want to know what you guys are working on. Any interesting projects? Any interesting projects that we can look at on the stream, if you don't mind, because I'll happily review some of your projects. So let's run it. No. No copyright songs. Right, so we did fail here in this case, so let's see why it's failing, which is 2. So we've loaded into that, and we didn't actually load anything, right? So that's what happened. So basically, whenever we execute the next instruction, we never kind of actually load it. So C8. Right, let's see what's going on here. Oh yeah, C8 is the Y. Increment X and increment Y. Okay, that was a bit embarrassing. So I should have been doing this one here. Opcode is E8. Yeah. Again, it's a problem with, it's a skill issue in this case. So it would have been E8 in this case. Right? Yeah, EA. Let's compile this again. Running the programs again. What do we have? Okay, things 0% passed. And we have a memory issue. Ooh, that's scary. That is scary. Address, deadly signal. So what do we have here? The signal is caused by read memory access. Address points to the 0 page. In this line here, test body. So programs. God, IntelliSense not working with modules is so annoying. Yeah, it is, Robin. I agree. Like, I'm having to just use the compiler as my IntelliSense. I am the IntelliSense, right? I'm not very intelligent, but I do have senses of how how this may or may not be working. Well, yeah. So what do we've got some issues here with accessing the program at +1 here. That is interesting. That is very interesting. I am the IntelliSense. Yeah. I mean, that's what you gotta do. You gotta do what you gotta do when it doesn't work. Let's debug it and see why this shit isn't working. Don't care about that anymore. Emulate TXA. We don't care about that one anymore. Increment X, right? So this program, for some reason, okay, so X is 2 in this case, and it does work. So now it should create a new CPU, and then we should have X equals 3 in this case when we run that, right? Which is... I'm good. And then we have another one. What? The program is 0. Why does it... What the hell? Ah, yes. See, I'll give you guys a chance here to spot the error. I mean, the first person that spots the error will... I don't know. You get a heart emoji on the chat, I guess, but can you spot the bug here? So I'll make it easy. This loop here is running, you know, for every program that we have here, but for some reason it runs more than 3 times. Another thing that the C++ compiler could absolutely help you with in here if it was Rust. Let's see. I'll give you guys like maybe 30 seconds or so while I reply to another text. All right, no one's gonna take on it. No one knows. No one wants to figure it out. There is a bug here. I'll give it 10 more seconds and then... Yeah, no one's able to answer, that's fine. Maybe no one's watching, but I'll go through it anyway. So basically, I just copied and pasted this bit of code from a different test, right? And in that different test up here, you can see that we have 5 elements here, right? So 5 different programs we want to test on a for loop. But of course, hello Slim, how's it going? But for me to be able to have 5 elements here as an array, I have to be able to provide how many elements I want in that array, which is 5. If I put 4 here, it doesn't work. If I put here 6, it does work, which is interesting, but the last element will just be a default initialized vector. That's what's going to be here, right? And this is exactly the issue that we have here, by the way. So in here, I have 3 programs that I want to test. However, this number remained as 5, which means we actually have 5 elements here. 2 of them are hidden and default initialized for us, which means that we don't have a program here. So it's an empty program, which kind of works up to this bit here. When it tries to access the program and memory, or the byte and memory 2 here, right? So the fix, quite easy, turn it into 3. But it's one of those things. I mean, if it was Rust, you definitely know about it before the program compiles. That's what I'm trying to say. And now we should all work as it should work, right? And this is a very this is a very flexible test, or a very symmetrical test, because we basically can do the same thing for int y. It's the same shit here. Is your love for C++ fading away? No, I still like it, to be honest. I mean, writing this emulator is actually bringing me back to my roots, man. Doing a lot of unsafe stuff that it's fun to write but hard to debug. That's how you can put it. So in here we have just the only difference is C8, and the only difference that we have here is C is Y. We can build it and the tests will still pass, right? So if we still run this test here, it should still pass as usual. Oh no, it does not pass. And why does it not pass? I don't know. Let's see. Failure which expected equals 1, which is 2. But the emulator doesn't do that. So let's look at it. Let's look at what C8 is doing. C8 is this one here and increments the registry Y. So this should be working, right? This should be working. Let's see. Let's debug it and see what happens. So Slim, how's it going, man? I mean, it's been a few days, and how's work this week? What test package are you using? I'm using just Google tests, nothing fancy. I want to try Catch 2 at some point. So Catch 2 is supposed to be a very good one as well, and I feel like it probably is the de facto test package for C++, just because it's better and it has a more modern syntax. So you can see it's written in C++ 14 and 17. And I guess it fixes a lot of the issues that Google tests kind of have. So I want to give this a try at some point, right? But yeah. And yeah, it gives you some micro benchmarking features. That's interesting. I'm trying to use Catch 2 for HTTP APIs for requests. So I'm trying to use Catch 2 for HTTP API requests. So you got me into C++. Ah, nice one. I'm glad you're enjoying it, right? So you don't give up. It's very difficult to learn it, but once you learn it, you learn any other language quite easily, man. I mean, C++ by itself is could be a low-level language. It's not really that low. I still think it's very high level, but it teaches you a lot of the fundamentals of hardware, which is a very useful thing to have. It's useful to know how pointers work. It's useful to know things like polymorphism and how it's implemented under the hood and what the compiler does. Things like, I guess, virtual tables. Once you learn all of that stuff, you can see how everything else is implemented in any other language, and it's just about transferring your knowledge to other things. I'm using C++ 17. Should I stick with that or upgrade to 13? I'm gonna be honest, dude. So just try and learn like the simple C++ stuff, like even the older versions of it. So I'm talking C++ 11 onwards. I mean, even 98 is pretty good. Even 03 98 is pretty good, because you're gonna see a lot of code written back in the day where they don't really have high standards. So it's useful to know how they work as well. But if you're just starting out, you just want to get a quick program out, then yeah, 17 is fine, man. You have all the stuff that you need there. The problem with like learning C++ 23 and writing programs that only use C++ 23 features is that as soon as you get a job in C++, I can guarantee you that that company isn't going to be using the latest and greatest compilers and versions or anything like that. It will just be like a very, very old tool chain. So it's useful to know how those work as well. That's what I'm trying to say. But yeah, learning modern C++, incredible. Anyway, so what's going on here? So we have execute into x. So increment y, and where are we? So we are emulator execute and test internal run. Which test is it? So run. Oh, there you go. So we are in int y. And which program do we have? We have, yes, it's because we haven't loaded anything into into y, that's the problem. Because now we actually have to load LDY here. A0 is the one that we're looking for. That's why things didn't work, because y was initialized to 0, and because it didn't change it, it was always going to be that. So it just got to change these things here. And again, it's just me writing bad tests. I should have been able to catch this. Let's build it and then let's run it. I didn't mean to. Okay, no, this is not the test. I meant to run the test, dude. Okay, run this again. Okay, so we have 100% passing tests. Very good. Now let's run. Shall we run the emulator again? So the actual application, and see wherever we don't have a. Oh, right. Wherever we don't have a instruction that we don't support, yeah, because that's what we gotta implement. So we stop there and let's see which command we don't support. So that's 202. So 202, what is that in? Oh, what is that in? CA is the one. So CA, which one is CA again? So C8 is here, increment, and then CA is this one. So let's see what CA is. I'm kind of gonna guess that it's a jump. Yeah, there you go. Jump to new location. Oh no, that's jump to new location. Never mind. But it's gonna be like a compare or something, right? So C. What was it again? You can see that my registers in my brain are very short living. I remember it for maybe 2 seconds. It's like a goldfish. So, right. What was the command again? So 202, which was CA. So C, A is here, C is there. So decrement X. Oh, do we have that in a program somewhere? Oh yeah, we do. It's this one here. So decrement X. Cool. Coolio. So decrement X, kind of very similar to the increment ones, right? It doesn't really take anything. You can see that it takes nothing at all. And it's just a decrement. Index, oh, unfortunately. Yeah, there you go. So I have decrement X and decrement Y and decrement. So we can implement these two in one go because they are very similar functions again. They do the same thing, so they just simply decrement the value of X. So again, we are going to come into wherever we had the increment function, so increment registry. I'm going to copy and paste this for now. And we're simply going to decrement registry. The only thing we're going to do here is that. That is it. That's exactly what we're doing. And we have this function now which can go down here. So which one is it? CA. So we have CA, the first one. There's a big beautiful switch case. We have CA. CA? It can be. Yeah, CA. So case, we are 0x CA. So increment registry, right? This is what we're doing. So decrement. So we have CA there, and then the Y version was simply 8A, right? 8A. ATA and decrement Y. Decrement Y. I could swear I had a decrement somewhere. LDA increment Y, CA. Increment X here. Oh, decrement X, right? Decrement X. And one very minor bug we have here decrement here, and we can do the same thing here, but this is y, and we're sorted. And now we're gonna go into our test again. I just want to make sure that we do test when we gonna make sure that we run some tests later on for when the flags are set in this case. Yeah, and now let's do the same test again for the negative flag. So TXA, not the one we want. Emulate in X. Now it becomes very much easy for us to just create these tests. But yeah, we're getting there, guys, I promise. Maybe another like 50 minutes and then we'll be able to see a whole program draw into the screen. And I'll tell you what, if anyone's actually interested in this and you want to create a 6502 program that will draw something to the screen, feel free to do that, because we might be able to emulate it later on. So if you are interested, go on this website here, create some program, and then I can run it in my emulator and see if it works. Right. Yeah, so this is testing those, and then we emulate in X. We want it X, no flag. So this loads something into X, and then we decrementer, which is a what was it again? Decrement X CA, and CA. We simply expect it to be -1 in this case, right? That's what we expect it to be. So let's compile that. And let's run it. Okay, 100% of the test passed. And now let's do the same thing, but we are doing it for the other registry, the Y registry. Programs, and then we load into these. Okay, we want it to be minus, and the only thing missing is the last one. It's not C8 anymore, it's going to be decrement Y, which is 8.8, right? It's the right one. It's so far away from the decrement X instruction. It's interesting. I thought it's supposed to be close by. So decrement Y is this, and decrement X is that. CA and 8.8, yeah, we're quite right. So 8.8 is the one. Mustafa, I don't know what you are doing. I just respawned. You use library or whatever you're doing. So Mustafa Gaber, welcome to the stream first of all, and let me give you a quick idea of what we're doing here. So basically, we are creating an emulator for the 6502, right? So when you have a 6502 program, which is a very old processor, 8-bit processor, which was actually used in the NES. So if you think about the Nintendo Entertainment System, that run this code here. So when you compile it, and you can, you get something like this, a byte array, right? So this byte array is a program. So we're just basically creating a program that will run this program in C++. We're creating otherwise known as an emulator. So that's what we're doing. And to make things a little bit more fun as well, we added a little screen. This is not the emulator I have, by the way. I'm basically just doing a C++ version of this one. To make things a little bit more fun, we are essentially adding a little GUI as well, which we already have, that draws pixels on the screen, right? And I've already crafted a little program here that will draw all the pixels on the screen. So if you assemble it and run, this is what we expect to see at the end of it. This whole program here is going to be compiled into this, and we are now trying to emulate this. Basically, we're adding support for each of these instructions in C++, right? I'm not sure if you can see it very well, but this is what it looks like. This is a program for you. Anyway, do I use a library for what I'm doing? Yes, I'm using a few libraries actually. Well, just one. So for the graphics, I'm using something called what is it called? The Ziglib? Well, I actually forgot what it's called now. It was actually, he's the man who suggested it himself. I'm using a very lightweight library for graphics called Raylib, right? So that's the only library that I'm using here. Obviously, I'm using gtest for the unit test and stuff, and FMT for nice printing. But yeah, that's what I'm doing. And hello there, Redemption. Hello, Al. Welcome to see you, man. It's good seeing you again, dude. Even on a Friday that you've probably been working all day, and somehow you still managed to join. So thank you very much. By the way, guys, don't forget to like the video, and yeah, don't forget to. I guess one of the things I could ask everyone here, if there's anyone still watching this, is to like the GitHub. Like the GitHub project. Make sure that you guys like follow it up as well. If anyone's interested in helping out this, you know, you're welcome to go and like look at the code and see how it's working. All you need to do is like you need to have CMake, probably a new version of it. I think 3.28 is the least version you need to have. So yeah. But make sure that you star it. Click on star here. I would appreciate it very much. Thank you. In fact, let me actually edit this video and add it. Ooh. Can I edit the video somehow? I'm gonna add the link to the thing here. So GitHub project. Saved it. Project. There you go. So Al, currently on vacation because of this the papers, but quite enjoy your streams. It's nice seeing you streaming. Thank you, man. Thank you. I'm very, very happy that some of you actually do enjoy watching me stream. But and I hope I haven't just broken the test by opening a second instance of a chat of the chat somewhere else. So let me do a test here just to make sure. Yeah, let me know if anyone's like sending. I guess you know, some of you are on my Discord, so let me know if the messages aren't coming through, but I can see them coming through. That looks interesting. Keep going, man. Good luck using Raylib. When I was learning CPP, it was interesting for me. Okay, yeah. I mean, it's definitely interesting learning new libraries, right? So Mustafa, what kind of how experienced are you in C++? I'm guessing you use the past tense there. When I was learning C++, that means you've learned it back in the day, and now you're a pro at it. What's your level of C++, dude? Right, so did we run this? 8.8, registry y -1. Just make sure that the tests actually work. Yeah, so the tests are still working fine. If I run the program that kind of has a breakpoint wherever we have something that's not supported, we can go on to our next instruction here, which is 224. Let's see what 224 does, and I hope it's not a messed up one, because some of these instructions are quite messed up. Like you have to do indirections and all sorts of stuff. 224, right? That's the one we had here. Yeah, 224. So next to that hexadecimal is E0. So what is E0 in the instruction set? Let's take a look. Let's take a look right now. So E0. Again, we use this very nice friendly website here. E0, which is compare X, right? So compare X, what does that do? So compare the memory and index Y. So basically, it compares that whatever is in the registry Y okay, so which opcode are we using? So E0, no, that's not E0. What am I doing? So E0 compare X. There you go. Yeah, so E0 will compare whatever is in X to the memory address. We have this one here, which is the immediate one. So in this case, what we do here is we're going to be comparing this one here, right? So comparing 0 to 0. We're going to check that the value on X, on the X registry, is equals to 0, right? And if it is, it's going to set some flags. That's all it does. So if it's 0, it's going to set, well, if it's 0, is going to set the 0 flag, definitely, right? I guess. It sets the carry flag. This is interesting though. I don't know what that means. What does it mean to set a carry flag here? Let me see what this does. So if we run comparing X here, so after decrementing X, let's run this program and see what we can do here. So if we do reset and we check the debugger, so most of I learned the fundamentals, and now I'm looking for advanced course or source to learn from to be an expert in the language. So I stopped learning for a while, but making simple games and with Verilib. That's cool, man. Yeah, I mean, that's a very, you know, for the guys that are here in the chat and were asking me how to learn C++, do what Mustafa is doing. So he's got a very good goal of, you know, getting better at the language, and he has exactly a project that he's going to do to help him get there, which is making a simple game of Verilib. Maybe I should start reading the author book. So the author book, yeah, I mean, I have read this book here, which is the Bible, you should call it. So it's the C++ programming language, which is actually quite old right now. Edition number 4 is the one I read, I think, and it was released when C++ 11 was released, and it's very good as a reference for C++. I mean, I wouldn't recommend reading it back to back just because it's very big, and whatever you're reading in one chapter, by the time you get to the end of the next chapter, you're probably going to forget without any practice. But do buy the book and use it as a reference. So whenever you see something in the language that you don't know, read the book chapter on it, because it will help you quite a lot. This is how I learn anyway, and it's how I kind of become very good at any programming language that I kind of set my sight to. So right now I'm doing the exact same process with Rust. I have a very good book for Rust that I use as a reference. Basically every day I read on things that I don't yet know in the language, or things that I've just seen a few times and don't necessarily understand. And I read the book, understand the chapter, and then practice it. That's the best way to learn, actually. So right, yeah, so let's kind of step it one by one, right? So we have LDA 01. Oh, okay, so reset, we assembled it. I don't know why this doesn't work anymore. Okay, let's assemble it, let's debug it, step, okay. So we just run this one here, and now we store it into B1, we're fine with that, and we load into X FF there, we load into A00, we store whatever's in A into B0, that's fine, and then we increment B1, whatever's in B1, we're not going to see that in here, and then we load into Y00, which is what we have there, and then we transfer over whatever we have in X to A, which is FF there, and we store whatever we have into A onto Y, into memory address, whatever's in this here plus Y, we're not going to see this, and then we increment Y to 1, and then we decrement X, so FE. Good advice, I would take it. Wish me luck. Yeah, good luck, dude. I'm sure you'll be fine, right? I'm sure you'll be fine. So we decremented X here, and now we compare. This is the interesting bit. This is where we compare whatever is in X to 0, 0. So what does this do to us? So I'm expecting this to set something to the 0 flag. So the C flag is set to 1. So I don't know what that means. What is the C flag? C flag 6502. because I thought that was the carry flag, and the carry flag is usually like whenever you do one number plus another number, if that number if it carries over, in other words overflow, then it will be set. In computer, the carry flag usually indicates the C flag. It's a single bit in a system status register flag to indicate when an arithmetic carry or borrow has been generated out of the most significant arithmetic logic unit position. Okay, cool. So let's look at the carry one. So after ADC, this is the carry result of the addition, okay? So it has multiple modes here. So after a compare is what we're looking for. So after SBC or compare, this is what we do. This flag will be set if no borrow was the result, or essentially a greater than equal result. Okay, so if X is greater than 0, that's what we do, right? So compare more than, compare with X. If X is greater than 0, then this is set. Okay, that's all we gotta know. So we gotta compare X, right? That's what we're gonna implement here. So increment, decrement, tax A, stud 0 page, and then we're gonna basically put all the compares. According to the documentation, during a comparison, the carry flag is set as if the two operands had been subtracted. So it does X minus whatever value I put in here, is that correct? So it does like X minus this, or this minus X. That's what I'm wondering now. I mean, this basically says, you know, if it's greater than or equal result. And instead of the subtraction, I can probably do, you know, the greater than or equal result, or checking for greater than or equals is probably quicker than subtracting. Gives an overflow and the carry has to be set, I guess. Yeah, so I guess... No, this is the other way around, I'm pretty sure, right? So we just set, we're doing like, is X greater than this value? That's what we're doing here. So like, we had FE on X, if it makes sense. Like, let me bump it up a little bit here for you guys to see. So I have FE here, and with FE, and we did a comparison to 0, 0, right? In other words, it did FE greater than or equals to 0, 0. And then it set the flag, as we can see right here. Oh wait, it's always going to be greater than or equals to, right? How can it be less? How can it be less? Let's read the documentation again. So compare the memory and index. I'm confused now because it's the documentation here says greater than or equals result, right? But if you do X greater than or equals to 0, 0, it's always going to be 1. So it's always going to be set. So I think this actually means if X is greater than 0, 0, then it will set the flag. If it's equals to, it will be 0. If no borrow was the result. It is weird, yeah. It states X minus... Oh no, that's not what it means, by the way. That means... Ooh. Yeah, maybe you're right. Maybe it just does X minus M. Because X minus that is... Yeah, and the result of that is going to be set here. Yeah, let's implement it the way he says. I mean, I'm happy to do it the way you say and then test it and see if it's going to work. So let's take a look at that. So if we do x minus the memory, so x minus that, and then the result of that, we check, and then with the result of this, we can do these flags, right? So if the result of this is a negative, or if it's 0, or if we carried over. Cool, yeah. I need to understand what this actually means, dude, because I'm a little bit not understanding here. Compare the section, compare functions. So let's do stud optional, and we'll do a size t for the bytes that read, and then we can do compare. Now we have compare x and compare y, they're both the same, and compare a. Yeah, so this way, I guess what we can do is we can do a general function here, right? So compare register, and again we're gonna pass in the emulator CPU here, and then we're gonna pass in a stud span of const uint8t for the program, and the register itself. So again, emulator, so std uint8t emulator registers, right? Is it registers or register? Registers. I'm always going to return 2 in the end. Compare reg, compare immediate. There are different modes on this one, and this one that we're doing is immediate, where we just check a hard-coded value. And we've got a typo here. And in this case, we do need to get the value out, so I'm just going to copy and paste this. This will get the operand after it. And I guess we can do, it's going to be the program .cpu. Oh yeah, so CPU .reg.pc plus 1 in here. And once we get that, what do we do? Yeah, we got the value, and now we can compare, right? So auto const comparison value. I guess we can do something like we do a CPU dot registry dot reg here as well. Minus whatever the value is, right? That's what we did. And then we set the flags accordingly, right? So we have a few flags that we want to set. So CPU.flags. I guess. Which one was the one? So this is 0. This is the 0 flag. No, this is the negative flag. And we have the C flag. Is it C flag? I can't remember now. How did I store the flags? Emulator is up here, and the CPU is the bit set of A flags. I mean, this is not quite right. What I'm actually doing is, I don't even know what I'm doing here, to be honest. So N is supposed to be, okay, I see, yeah. So 0 flag is the second one. Yeah, so N is like the 7th one. Matt was wondering, why haven't you added an enum with 0 to 7 to make the flag mapping easier for you to handle? Good suggestion, actually. I should probably do that, to be honest. I was hoping that in the bit set we would be able to say like flags.a is equals to the first bit or something like that, but I guess not, right? That's what the C++ bit field kind of does. Maybe we do a bit field, by the way, because I think it's just easier to use. So you can see, you know, you can do something like this, to be honest. Does it make sense? And I can just do like a whatever .a, whatever .b. So yeah. And in fact, I'm not entirely sure that this is the bit sets are the way to go, just because we can name bit fields as well. Like we can name them, and that's kind of what we want. So let's see, bit set named. Is there a way to kind of do what I'm trying to do here? Yeah, let's keep that in mind. I do like the suggestion though. Maybe we add some enums that will tell me which position those bits are, right? Which is good. So yeah, let's do that now actually. So do we want to export the registers? Probably not. So enum class flag bit, and we can do it as, I don't know, whatever, doesn't matter. And what are the flags that we have? We have n, which would be 7 in this case, and then we have v, which would be 6, and then we have no unused 1 here. And then we have whatever, b is going to be equals to 5 in this case, and then d, which is going to be equals to 4. No, 6, this is 4 actually. 7, 6, 4, 3. And then we have I, which is equals to 2. And then going by that we have z, which is equals to 1, and then the carry flag, which is 0. Right, that's kind of what we want. So it makes these things a little bit easier now, because we can, I guess, we can export that. And then everywhere we use that, we can just do a flag bit or something, or emulator flag bit n or something like this, right? That's kind of what we want to do. No operator matches the operand. Oh yeah. It's even better instead of this, right? What we can have here is just, I guess, the const expos, right? Now integer, I guess size t, right? And then we had flag n is going to be 7. And we kind of did this for all of the others, right? 1, 2, 3, 4, 1, 2, 3. And there's no conversion errors there. I would suggest readable names like negatives, carry, easy for you to, yeah, it is, but at the same time, like all of the assembly code uses just the one letter words, so I think it's easier in the long run actually to match what we're going to be running anyway. So we have b equals 4, and we have d equals 3, I equals 2, z equals 1, then we have the carry flag equals 0. Okay. Forgot to write the export. This should compile. And then in here we can now just do something, emulator.flag negative. And then the same thing for this one. So emulator dot flag 0. And for this one, we can compare that this is equals, this doesn't mask with this. That's what it means to be a negative number in 2's complement, as we've been talking about. It's a negative number if the last bit is 1, and the 0 flag if the value is equal to 0. And CPU.flags. Now this is the tricky one, right? The one I didn't really understand very well. So flag carry. If flag carry, how do we check this? So that minus the value. Yeah, this is the tricky bit that I didn't really understand. Let's try and read. In fact, can ChatGPT help us here? So explain how the compare X instruction works in 6502 assembly, and how is set the carry flag. Let's see if this is gonna. Yeah, comparison more than 0. I guess that works, right? Because if it's more than 0, then no, but it's always going to be more than 0. That's what I'm trying to say. Oh, right? I don't know. Not if they're the same value, then it's going to be. Then that comparison doesn't work. But maybe you're right though. Maybe that's all it does, right? It just checks if it's more than the value. So the CPX instruction is used to compare the value of the X registry with a specified value in memory. It operates by subtracting, there you go, operates by subtracting the specified value from the X register and then setting certain flags based on the result. So fetch operand, the CPU fetches the operand from memory. This operand is the value to be compared with the X register. Subtraction, the CPU subtracts the operand from the value stored in the X register. This subtraction is performed in 2's complement representation, right? Status flag, after the subtraction, several flags are affected. 0 flag. This flag is set if the result of the subtraction is 0, indicating that X register is equal to the operand, right? Negative flag N. This flag is set if the result of the subtraction is negative. This flag is set if, yeah, so negative just means we know what that means. Now this is the interesting one. This flag C is set if the subtraction causes a borrow during the operation, which is what you explained, right, Al? The only problem is that I'm stupid and I didn't get this. So in the context of CPX, the carry flag is set if the value in the X register is greater than or equal to the operand. It's greater than or equals. I still don't get it. The carry flag is set during the subtraction process if there's no borrow, which means the value in the X register is greater than or equals to the operand. If there's a borrow, the carry flag remains cleared. This instruction, maybe this example will help a little bit. This is CPX 10. This instruction compares the value of the X register with the value located at the memory address 10. After execution, the status flags are updated accordingly. Okay. In summary, the CPX instruction subtracts the specified value from the X register, and sets the carry flag if there's no borrow, indicating that the X register is greater than or equals to the operand. The value X register must not be always greater, wrong, sorry, needn't be. So, I still don't freaking get it. I need an example. Give me different examples. Compare X can set the carry flag in 6502. So load, this is a good one. So load X register of values 10. This is wrong, by the way. There's a missing $sign here. Compare the X register with the value 10. In this case, both the X register and the operand are equal. Since the X register is greater than or equals to the operand, the carry flag will be set. So X greater than the operand. So here the value X is greater than 10, thus the carry flag will be set. X is less than that. In this case, the value in the X register 5 is less than the operand. As a result, the carry flag will not be set. Okay, so we're literally just comparing that X is greater than or equals to whatever we put into here, right? So basically, CPU.reg yeah, so if this thing here .reg is greater than the value, greater than or equals to, that's it. I don't know why it took me so long to understand this, and I'm sorry, Al. I know you explained it very well, but I'm just very stupid, dude. So that's what it is, basically. Which is fine. I mean, let's go back to supporting this. You know, once again, we can see that AI isn't that good because it wrote incorrect assembly here. There should be a $sign on these things. So. Or is it doing it in decimal? I think it might be doing it in decimal then. Anyway. Going back to this. So opcode is E0, right? So E0 is the one we need to do for X. 3.5 is bad, yeah. So let's go into our emulator. Where's that big ass switch case? So which one is it again? So E0 is what we need to do. So E6, we're gonna add it here. Case 0x E0. And we have compare X in this case. So byte thread is equals to compare immediate registry. We have the program itself, the CPU, and then we have the spam, the program spam program, I guess, and then the registry, right? So the registry is emulator registers and X here, and we pass in a pointer to that, and we break out of it. And we do the same thing for the other one. We've just added support for 2 of them. So this one here is CPY. So we did the same thing. The opcode is C0 though. I'm just gonna copy this. C0 is what we're looking at. It'll be around here somewhere, right? C0 and compare Y. That's it. Good. Now we can obviously, you know, write a few tests. I'm just gonna assume that this works. Or should I actually write some tests? I think we should actually write some tests, right? Let's do this. This is going to be interesting because I'm pretty sure that we've probably written this incorrectly. And again, we need some to-dos here. So to do test DEY when we have flags being set. So we're emulating here, compare X, no flags set. Oh, should we do no flags? No, we need to do some flags. Compare X, Y, you know, same value. Because then this is an interesting one. So say we load into X. Again, what is load into X again? So LDX in this case here, A2. A2 is what we're looking for. A2, A2, and A2, right? We load 1, 2, and 3. And the same values, and now we want to compare with X. So compare is CPX E0, right? So we do E0 here, and we compare what? 0x01, and then here again E0, 0x01, and then E0 here, 0x01 or 02. Now what do we expect for each of these programs? We certainly expect the value of X to be 01, right? So the program 1. By the way, it doesn't actually set, and it doesn't store it anywhere, right? Yeah, it doesn't store it anywhere. It just does a subtraction. If it's stored anywhere, there will be like a little arrow here going into X, like in some of these, like as you can see here. So we've done the implementation correctly. So now, what do we expect in terms of flags here? So in terms of flags, I expect some of them to be, I guess, you know, assert equals here. This looks interesting. I might try implementing an emulator myself. Yeah, dude, I'm having fun, but it's boring work, do you know what I mean? Like, I'm just essentially doing the same thing over and over again, which is like reading the opcode and then trying to implement it correctly in C++ and writing some like unit tests for it to make sure it works, so. But the cool thing is, like, we're already on, I think it's something like, you know, E0, this one here. So once we have D0 here and C5 implemented, or this might be one instruction, we should be able to get this whole program running. So I'm hoping to do that today. I'm hoping to do that today. So yeah, so we have CPU dot flags, I guess, emulator, flag n is going to be right. Is it negative? No, we expect it to be negative for every single one of those, right? Ooh, I've got a flags, not flag. The other one was 0. Are any of these 0? No, none of these are 0. We have quite a few different cases actually that we want to do. Now the interesting one here is the C flag, right? So the C flag should be set because these values are the same, right? This is what we have. These values are all the same. That's what we expect here. So we've got the flags here, and let's build this and see if, you know, this particular case works. That should be 1 because the values are the same for your test cases. So Z, yes, that's correct, because it does a minus, right? And the result is 1. The result is 0. Thank you. So you probably helped me out a lot. Although, like, as soon as we run the program, we would have noticed that, hopefully. And it doesn't work. Why? Export declaration appears within another export declaration. Okay, so we don't need to export these. Nice. I guess when you do an export namespace, it's all exported automatically for you. Let's open a test and run it. So we failed. Let's see why he failed. It's gonna be this one, 100%. This song kind of sounds like Take On Me. Take on me. Right, so no, we don't care about that one. Same values, right? So what do we have here? So we have registers x equals 1. And what flags do we actually have? CPU flags. Oh, I can't see them, can I? Ah, okay, so we failed because we forgot to change some of the values here. So PC should be on 5, or it should be on 4. 0.3 equals 0.2. Your last case is wrong. My last case is wrong. Yeah, I see. So it should have been that. Thank you very much. Right, so let's run this again. So it still fails, but why? So when we execute the program, what do we have now? We have registers all fine, PC counter is equals to 4. You should get past the PC counter check at least. But the flags, this is the issue. So the flags N are non-zero, so negative. Yeah, it's not going to be a negative value. Flag Z should be equals to 1. Okay, so the flag fails. So the flag was 0 and we expect it to be 1. Which is fine, right? So we can kind of go into the emulator and then check wherever we did the compare immediate, put a breakpoint here and see what's going on. Okay, so let's see this one. So the value is 1 in this case, and we have 1 in the registry, right? Yeah. So N flag is that, yeah, 0. Ah, yeah, we're not actually doing the shit here, which is, yeah, we should be checking the comparison really here. Right, that's what we should be doing. Value equals 0, correct, shouldn't be compared. Yeah, exactly. We both got there. Let's debug it now. Actually, let's just run it and see if it works. There you go. So now it all passes. I think this is a little bit more solid, right? And I'm kind of happy that this kind of works now. The delay, yeah, the delay. If it wasn't for the delay, it would be a lot quicker. And you'd help me out a lot more. Now let's do another few tests, because I still don't think this is kind of working very well. This is why you should always write tests after you do your program. I was just saying that. You don't write tests, your program is not going to work. So emulate, yeah, same values, non-zero. Now we have 0. I mean, it doesn't really matter if we have non-zero values, right? Because if we change these to 0, same values, non-zero. Like, this name doesn't make sense for the test. But if we do CPX with if X is actually less than the thing, what should we call that test? So set carry flag. Right, that's what we expect to set. So if we set 0.1 here, but we do like 0.2 here and 0.3 and then 0.4, what we do expect here is that this N flag will be 0, this flag will be 0 as well, but then the carry flag will also be 0. That's what we expect. Lucas, you Brazilian, mate? Yeah, mate, I'm Brazilian. Sou brasileiro. I've been living in the UK for a long time now, so... But I'm from Brazil, Sao Paulo. Now let's try and like compile this and see if it runs just fine. Right, so... I mean, if it works first time, I'm happy. And it doesn't. Of course it doesn't. Yeah, let's see what's going on. N should be 1. So N should be 1 because it's... Oh yes, because it's a... The result of the operation is going to be a negative number. You're quite right. You're quite right, because it wraps around to a 2's complement number. So 2's complement negative number. Okay, yeah, so that's working a little bit better. Now, are there any other edge cases that we haven't really done? So we have the same values, and I mean, the only, not really an edge case, but the actual happy path, which would have been something like when these values are, when x is greater, right? Compare x greater. Great content, by the way. Thank you, Lucas. Thank you. Bem-vindo ao stream. Espero que você goste, cara. So if you like C++, then you're welcome to watch me just code away. Yeah, this is the right place, man. Come chill with us. By the way, Lucas, I appreciate if you drop a like on the video, man. Really helps YouTube's algorithm to suggest my video to other people like yourself. So yeah, thank you very much. So compare x greater than value. So if x was greater, right, so something like 1 and we're comparing it to 0, comparing it to 1 and comparing it to 2, this should really be kind of the same test as we had with the other one. So it's not going to be a non-zero. It's not going to be, sorry, it's not going to be negative. It's not going to be 0, and the flag is going to be set. So I just started analysis and systems development. I'm going to be checking your channel often. Thank you very much, man. If you want any particular content or you have any ideas, I can always do a video on whatever you feel like it. Okay, so it did fail. Did it fail? So the 0 flag is supposed to be 1. No, the 0 flag is supposed to be 0, right? Yeah, that's the one. Yeah, the 0 flag is not supposed to be on because it's not a zero result. Man, I'm just writing buggy tests today. Jesus Christ. Okay, right. I'm happy that this works a little bit better. And now let's run the actual program and see what the next instruction that we're going to support has to be. So we compare it and then... Right, is that everything? We support everything? No, it can't be. That can't be right. It just can't be right. There's no way. Okay, so whenever we hit this, we want to put a breakpoint here. Okay, so what's the next instruction that we don't support? That is 208, and let's see what that 208 function is. So 208, we're looking at D0, and as usual, we're looking at D0, so we're going to look at D0 right here, right? So D0. Compare X. No, that's wrong. What? D0? Is that correct? That can't be right. We already have D0. Why do I have Urchinum? So 208. We have 208 here, which is D0. So D0. Oh, there you go. Of course, it's BNE. Because what comes after compare? Branch or not equals or branch on something, right? You clicked on E0 or not? Yeah, I think you did. I don't know what I'll do that. The day you can't join the stream is the day that we won't be able to kind of do anything. Right, so branch not equals. So I guess this will branch on whenever the carry flag isn't set. Oh, Robin, you actually made a program, dude. I'm excited to do this. So what is this program doing? Let's run it through here first. All right, let's see if I can read it. So you load into A0 and you store it in 200, and then okay, cool. So you just do 3 pixels, right? Right. So if we assemble it, now the thing is, why is this not running? So if we reset and then run it again. No, you need the whole file. It's large. Oh right. Oh shit, I didn't realize. It's large. So have you like written a picture? See, we can already do this. Oh, man, it is large. So he wrote a program that will draw a picture somewhere, right? 32 by 32. I can guess that's what you did. I'm glad to do this. Let's see, hex dump. Now, if we do this, emulator isn't very good. There is a better emulator, so 6502, that will actually download me the binary, this one here. So if we paste it here, And if we kind of, wait. If we paste it into the assembler and we assemble it and we download the binary, we should already be able to run this, because I can see that we don't really have any instructions that we don't already support. So let's generate, click here to download. Right, so what do we have here? So we've got Robin's code. I'm excited to run this now. So if we do mnt c download users, download Robin's code into here. There you go, we've got Robin's code.binary there. Let's run it. Let's see what happens. I'm very excited. Hopefully it should be able to run the entire program though, without any failures, because we have tests. But if we click on this and we stop running, oh, we do have a function that we don't support. What is that? 1411 141. What? What do we have here? You just have LDA and SDA. I'm so confused. Do you have like a sneaky little instruction here that we don't yet support? Ah, yeah, you've got some, yeah. Basically, you've got this SDA. Yeah, this is what we don't support, but we can do it now. You have the function that stores from the accumulator the value onto the memory address full, right? So we support this one here, which is like just 1 byte, which is the 0-page one. We need to do SDA for the whole thing now, and let's do it now, because I really want to run a program. So let's rerun it and then just see the exact opcode that we need to support. So we have 141. So 141 is the one. So 8D, right? 8D is the one. Back into the instruction set, 8D, 8. So these here, and 8D, right? The absolute one. So the opcode is 86. We need to support that one. And you can see what it does here. So it just stores the value from the accumulator. No, I clicked on the wrong one. Surely, because it's SDA, right? That's why you have SDA. Yeah, SDA. And it's AD. Did I click on the wrong one again? Yeah, there you go. SDA, this one. It doesn't say any flags, so this is a very easy one actually. So we already have an SDA here. I'm not even going to write tests for it. Is it A5? Oh my god, I'm losing it. I am losing it. AD, SDA, yeah. AD, this one. This is the one we have to support. Matt, look at the top of the page. You are reading the wrong function. Thank you. Yeah, I was reading the wrong function. You can see that my brain isn't meant for this anymore. So this is the one I need. And so what does it do? No flags. Just write it to whatever we have here. And this is little endian. That's the only thing we have to know, that this is little endian. So we have to basically flip the memory addresses, right? So, right. AD. We're going to be reading 2 of them. So we have, so this is the lower bit, LSB. And then we have the higher bit. And this is going to be PC+1 and PC+2 here. And we're going to read as bytes read. It's going to be 3 in this case. And instead of store 0 page, ooh, no, we're going to have store. simple store here, which is going to take a word. I know word is 16-bit, right? Yeah, so it takes that, and this is the address. Navigation of the page is god-awful. It's god-awful, dude. That's why I get confused all the time. So we have the address here. AD, so we have store absolute in this case, and then we have the value. Now the thing is, we need to kind of do it in such a way. So we need to put LSB first, or high SB, plus LSB. But this has to be plus, I think, 8 bytes, right? So that's how we do it. And that's how you convert from little endian to the address that we want. So that's what we're going to be doing here. So what we want to do is do the high SB plus 8 in this case, plus LSB. This should always give me a valid stud 16, right? But yeah, let's read it now. This is, I shouldn't ask this, Robin, but this is not rude, right? It's not, you're not going to draw something like a genital in the screen, right? Let's put it that way. I'm going to run it anyway. No, okay. I mean, it works. The problem is we only have the same color in all the pixels. So let's change that right now. No errors, which is good. And we support every single function. But the only thing is that we have to do is like to actually put different colors. So I don't know what the color scheme is for that website, but I'm gonna guess, I'm just gonna use this again. I'm just gonna use this. So generate a 16 color table in a C++ array where every color is denoted as the initializer RGBA. The values R, G, B, and A should all be between 0 and 255. Should all be integers. The value A should all be 255. Make the colors A should, yeah, we got that. So A, make the colors different enough. Right, amazing. Beautiful, right? This should be valid syntax as far as I can tell. We're obviously gonna just show up a little bit. Right, so we have 16. Let's compile this again. You know, this is the power of AI to you guys. Just make tasks that you can't, like you can just automatable. Now the thing is, we still have red everywhere, which is not nice. Where are we drawing things? So here. So color table ID. So ID, clear background black. Why is it always drawing red? Let's debug that. Exciting. So color ID, this is red, yeah. Color ID is 0. CPU memory I. 512. IS++, yeah. So the first color is red. What's the second color? $13. Oh, you got the palette as well. Thank you, dude. I'll do it up in a second. Now the thing is your color, you're setting different colors, right, for the first 2 bits. So you've got 0 here. Oh no, they're all 0 for a bit. They're all 0. So LDA 0, 0, 0, 0. When does it not become 0? Okay, so it doesn't. May I need to do some ChatGPT magic. That is the color palette I use. Okay. 16 is 1 and not 0. And we do have something in memory where that makes sense, right? So memory. Oh, the thing is I can't inspect memory. Kind of shit. And we are setting memory, right? In the emulator, we are kind of setting. STA 0 page. Store into the store absolute. The memory address is always going to be whatever's in A. Come on, do work, do work. So the CPU, how do we create that? So is a reference. And I'm using the same reference, right? I better be. I'm wondering if like the same reference is used everywhere. Like it's not just copying the CPU eventually. So execute is the 65k reinterpret cast of my data. Program contents.data. If the memory address will always be in A, then you flipped your assignment, I think. If the memory address will always be in A, you have address equals A. So these are STAs here. So the value that we want. So this is the memory, right? This is like where in memory we want to store the value of A. Ah, yes, yes, of course, Jesus. Dude, you are a genius. That's probably why it wasn't working. CPU. Oh no, that's right. Wait, what? Yeah, whatever is in... No, this is right. This is correct. Yeah, you have address equals A. So we want to store the value of A into the memory, into this bit of memory. This is not incorrect. I think this is right. If you look into this, so, you know, it takes the value of A and stores it to M. That's what we're doing. Can I print the vector? Can I nicely print the vector? What's the nicest way I can print the vector? Or I can dump it somewhere to see what the memory looks like after. Oh, gosh. I am not quitting this stream until this works. Color is 5. Color ID 0. So the color ID is always 0. It doesn't seem to be anything else though. Yeah, color ID is always 0. So it's like the memory isn't being set. Or what I think is happening is that the bit of the program, this async here, is it taking a reference? So this takes a reference to the CPU here, and it draws the CPU. And what does draw CPU take? All right, so it's not copying anything. So maybe this bit of code is not actually taking the. Oh, it's doing a copy somewhere. I'm pretty sure, right? Let's see. C++ async send reference. C function. I must be calling async wrong because it's doing a copy instead of like taking an actual reference. Do you know that const reference variable in C++ does not point to the original variable when using stud thread and async? Yeah, I do know that. That's why. Okay, so what the heck was happening here? Yeah, the addresses are different. So what do we do? How to convert argument to an R value? We just need to do stud reference classic to R value. That's what I have though. Give the CPU an ID member and assign it to it. You can check the value in the draw method. Yeah, I can do that. So whenever it gets copied over. But this should work though. Yeah, this should work. Yeah, what I can do is like we can, as you said, we can probably put a CPU, a thing here where we say static int ID. Does that even work? Is that how you do member? Yeah, I think it is, right? So static int ID 0, and then whenever we do, so member with an in class initializer must be 0. Ooh. Wait, how the hell do you do like static members again? Do they all have to be static int? Yeah, I mean this should just work. Why is it telling me that it doesn't work? Static int next ID equals 0. And then when we do the CPU, or just CPU here, why does it not let me initialize it? This is annoying. So int a declaration incomplete type, definition complete type. So must I declare it after? We can probably just set it down here, right? So CPU. There's no storage class or specifier. I just want to initialize an integer. Jesus. A static data member may be declared in inline. An inline. Okay, maybe I have to do the inline static because it's in a header file or something. Well, it's not really a header file, so I don't see why. This is for like the one definition rule, basically. But I thought that this wasn't the case anymore with modules. You can see, kind of annoying, but oh well. Anyway, so we do have an int here. Just call it ID. Right, so we can set this to ID equals, and we also do the class here, so CPU next ID. Right, does this compile? Let's see. Okay, Yeah, so let's see if this is like being copied somewhere. Actually, if it's being copied, it's not going to be this constructor though. It's going to be one of the copy constructors. Right, so something like this. Right, so if it's been deep copied, well, I want to see which one it is, by the way. That's why I'm doing this. Right. Let's figure it out. So emulator. Where's the app itself? Main. Right, so this particular CPU is next ID 0. So it's the same one. Is it the same one as this one? That's what I wonder. Yeah, next ID 0. So they are the same object, as far as I can tell. So yeah, something fishy is going on with me setting the program. First of all, what is the program? Do I have the right program being passed in? Because if it is just that, then yeah, I mean, it seems to be the right program, right? Yeah, it seems to be the right one. I think it's the STA underscore absolute. Sorry, YouTube blocks that thing. Yeah, let's take a look at it. So STA. So memory address. The address is going to be equals to whatever is in A. I don't see how this is wrong. But we can do a few runs, right? So this is an A. A is 0. Right now the address is 512. What we can do as well, like we can see when something like, you know, if in the CPU or the CPU.reg.a isn't 0, which is going to print something out. So stud cow. We can even do, I guess, FNT. Oh, this is Nintendo. Nintendo copyright incoming. Reg A. Is this also Nintendo? Jesus Christ. There you go. Storing this to the memory address, right? Maybe I've messed up on the conversion between the values there for the memory addresses, right? So we'll see. We expect the first one, the first non-zero. Let's look at the non-zero one here. So 000, 000, LDA. When does it become non-zero? LDA there. So LDA 0B, 0B. So 0B is the first one. So we expect the first non-zero value to be this 11 in decimal. And this is our what memory location. We expect 0285. So we expect 11 at 0285 right here. which is decimal 645, right? So that's what we expect right here. So memory address 6045 is going to get 11. I'm just going to put that there so at least I know. I need to compile this again. So this never happens. RGA never happens. So close now, yeah. But it will work because that means the problem isn't here. The problem is this instruction here, LDA. So LDA is the issue. So load into the accumulator. 0 page, is it 0 page? Yeah, load into LDA, which is A9, LD immediate. So this isn't quite right. So the register is equal to the value. So let's put that in here too. So if we do, if the value isn't 0, so again, the first one we expect to see is LDA, so this one here, right, 11. We expect to see 11 here. What's the issue though? What is the issue? What? Oh yeah, print line. This should have been format. We're getting there, guys. We're getting there. Right, so what the hell? What in the hell is going on here? So it's not even going into this function. Why is it not even going into the function? It's got to be a bug that is somewhere in here, right? So execute. Let's see this. So the first one. What the hell? So it does read the entire thing, at least, like the program. So if I do out of interest, what comes into the program? Like, it's still reading, by the way, still reading and reading. Could that be why? So the PC counter is never less than the program size. It just can't be that slow, right? Surely it's not the issue. The slowness is not the issue. See, even now, I do this. What's the PC? PC is always 1. I am so confused. So the command in this case is 0, which is a break. What in the hell? Let's see the flow of this shit, shall we? I like this song, it's quite calming, but I know it's gonna hand me a copyright. Let's play it for a bit. Right, so the first one, we have PC is 0. And we read 2 instructions, right? And we increment it, so it should read the second one now. So we've just read the third one. So it should be a 5 now on the PC, which we are. We're a 5. And then maybe increment is 2 again. And then 2 again. And then 2 again. This is wrong though. This is definitely wrong because it should have been like we read the first one, which is a byte. We store it there, which is 3. Then we read the second one, which is 2. And then we read the third one, sorry, the fourth instruction, which should be 3 bytes. So why is that one not returning 3? Let's figure out. So the first command is 169, which is A9, so LDA, that's fine. Second command, it should be the store one, so STA this. And if we store that into the registers, into the memory, there you go. So we can see, fuck. We can see if it's stored in 0200 now, right? Zero 0200, what is that? 512, right? So 512. So that hasn't done anything. Like, why not? And 0200 is what we want, right? Oh no, that's fine. That's storing a 0 anyway. Well, anyway, the bytes read is 3, and we increment it by the PC by 3. So we are now on 5. So this is 1, that's 2, 3, 4, 5. So we're reading this instruction here, LDA now. That's what we expect. I wish I had more knowledge so I could help more. It's alright, dude. We'll figure out. Like, it might take half an hour, it might take 10 minutes, but we'll figure out. So LDA is the command that we want to go for, right? Ooh, but it's not what we found. So we found a bug here. So let's see. This first command is loading into the accumulator, right? Which is LDA. It goes here, right? That's what we do. LDA there. And increment it by 2. Next time around, we expect to store into the accumulator and the increment to be free to the PC counter. So store into the accumulator that you're using here, Robin, takes 1 byte and then 2 bytes for the address. So we increment it by 3 bytes, right? That's what we expect there. So we're STA, bytes read is equals to 3. And we return the bytes read equals to 3, and then we increment it by 3 in this case. Now PC is on 1. What? I found the bug. Is it because it's a uint 8, right? So this should have been 16. In LDA you have +2 instead of 3. LDA, you have +2 instead of 3. Load into the accumulator. But it's 2 though. Is correct, ow. LDA should be 2, it's just 2 instructions. So the first byte is the actual instruction and the second byte is the immediate address. So this is a byte here. That's correct. I think the bug here is because it's wrapping around. Because PC should really be a program counter, which is a 16-bit integer, right? Let me just make sure. I think that's the issue. So there's flags. So 6502 registers. So processor status, PC, where's PC? Program counter there, 16-bit, and we had it just 8 bits. I think that's the issue. The stack pointer, the processor supports there. The stack pointer is an 8-bit. I think they're all right, except the program counter. They're all 8 bits, right? 8-bit integer. There's another 8-bit integer, and then the accumulator. Right. That's one of the bugs. We found one of the bugs. I think there's probably more than one, but we'll see that. So let's run this and see. So the first one is LDA, which we know is 2 bytes here. Bytes read is equals to 2. Can you quickly go to STA? Yeah, we'll go to that in a second because that's the next instruction that we're going to run here. So execute that, and then we have STA here. So if the program counter plus 2 is in range, which is fine. This is fine, by the way, because the program counter is already at the address, and I want to make sure this check is making sure that you have 2 bytes after the program counter to read from. So we can do this here. This is what I'm doing. So PC right now is 2. And what comes into the address? So the address is 512, as we expect. And we put that into the memory. So 512, fine. And we read 3 bytes, fine. So what we've done is we've run these 2 instructions right here. We expect LDA to be the next, right? That's what we do. Right. So we do LDA now. The program counter is where? So PC is, why is it 6? What the hell? This isn't right though. This is wrong. There's an overflow going on somewhere. Like I can't figure out what. What the hell? Right, let's remove these breakpoints. Here. Yeah, that's a bug. That's definitely a bug. The 600 should not be the program counter there. It should be something like 5. Right, let's run it again. First one, see the PC 0, and we increment it by 2. Next time around, the PC is 2, and we increment it by 3. This should be 5, right? That's what you'd expect. The PC is 5. Now, at this instruction, what do we have here? So the command is LDA. Why is it maybe increment? It's maybe increment because it's an optional. So it's just a way for me to write that it may or may not be a value. So, so bytes read in this load immediate. Let's see what happens here. So we do have that. And the program at PC is 5. We try to get the program at 6, which is 0. The value is still that. So the value at A is 0. So the maybe increment is 3. What the hell? Can you see this? How is it incrementing it from 5 to 6, 7, 5? This is not going to be fun to debug. Could it be that no value is incremented and then the program tries to add some magic? No, because we can see the value in the maybe increment. If this was null opt, then yeah, then that would make sense. But I'm checking it explicitly here. If there's no value in there, if this is an optional, then it shouldn't work. So let's go to whenever this is 5, right? So 2, then we're at 5 now. And this is where it gets interesting. So the PC is 5 here. So the program, the command is there. So CPU here, we're looking at the register. So PC is still 5 in this case, right? So PC here, still 5. We can all agree on that. PC here is still 5 as well. Now the registry, what was the call stack? Should have been A there. Okay. So in this case, PC is still 5, registry is A. The flags is are just 0 and 0. So the PC here is still 5. We can agree on that. So maybe increment is 2. And the PC in this case. I am so. Okay. This is going to be interesting. This is very interesting to debug. To be fair, I'm gonna be honest with you, it's probably because there's another thread here that's drawing shit, right? So there's this thread that's literally just reading the values to draw on the screen. So that's probably what's going on here. So for example, if I didn't have this one, I would love to join in Discord and debug it. Yeah, I mean, we can do that. Use of undeclared identifier, okay. You did it to fix mutex, maybe that's the issue, yeah. It probably is the issue, but the thing is I'm just reading from the other thread. I'm not writing anything, so it's a weird one. Let's run the emulator again and see what happens, shall we? So maybe increment. It probably is, like, I wouldn't be surprised if the issue is that. So 5, and then we have 2, then we have 5, then we have 7 here, then we have 7, then we have 10 here. This is working a little bit better. Then we have 10, then we have 12, right. I'm pretty sure that that's the issue. What can we do here though in this case? A nice quick fix for this now is to remove the async, and we can deal with that issue later. I'm gonna deal with this by simply removing the need for async in this case, and simply just calling the function, right? So just doing we're gonna emulate everything first, and then we're gonna draw. That's what we're gonna do. But that was interesting though. Interesting that we... Oh, right. Yeah. Easy 65k. It's not so easy now, is it? Right, is this just gonna work forever? Okay, eventually we'd load a lot more stuff now. You can see the printouts there. And we have a very beautiful heart. Thank you, Robin, for doing this. Now let me actually try your color palette though, because that is gonna be more interesting. I think we have it up here somewhere. Ooh. So yeah, guys, maybe don't just ignore memory, like data race conditions, basically. Do not ignore them. They are bad for your program. That's what we learned today. Oh, in Discord. Oh yeah, shit. I'm looking through it here. Yeah, so we're gonna have to convert this with ChatGPT because I can't be asked doing all the work. So convert the following array into a palette into a array of RGB values like the above examples, except convert to valid C++ syntax with decimal values. Does that work though? So you have FFFF. I mean, I'm assuming that it's going to work fine, right? We'll see. This was so stupid and insane. Yeah, it was really stupid and insane. But I mean, to be fair with you, like, I figured out it could be a data race condition as soon as we saw the value going from like 5 to something like 600, because that doesn't happen. Obviously, it doesn't happen unless you have like a data race condition. So be aware whenever you're seeing things like that, it's probably a threading issue that you have. No alpha there, you need there. Ooh, okay. Add alpha values to the above RGB values where they are all 255. Okay. Right, are we ready? Let's go now. Shouldn't I mean your drawing thread was changing the CPU? It does, yeah, it does mean that, but I don't understand how, to be honest, because no, it was just viewing it, which is interesting. Yeah, I don't understand how he was changing it, to be honest. Like, I can't see any changes in the code. I mean, I've only got this reference here to the CPU, but yeah, interesting one. This is beautiful. This is absolutely beautiful pixel art, and I think I'm probably going to change the thumbnail of this video to this, if you allow me. And I'm going to say it by Robin, so why not? Let's do that right now. Thank you, Robin. That's beautiful. He made my night. Indeed, yeah. So out of interest, man, how did you convert to this? Did you get GPT to do it, or did you write like a program that would convert every pixel value to? I sent an upscaled version. This is the upscaled version, by the way. Very upscaled indeed. But it looks nice, dude. Regardless, it looks amazing. Here. I'm gonna put it here. And pixel art by Robin. That's what we're gonna do. Ooh, still a bit of magic now. Why is the text so big? That is my icon for my currency on Twitch, actually. Oh, that's amazing. Do I want this one here on the back? Not anymore, right? We can just put it away. Now, it definitely doesn't look good as a thumbnail, but we're doing this anyway. There you go. Well, I'm working on one more. Will you also be shifting towards Rust, especially now they are talking about pointer-safe language? SappyDev, that's a very good question, dude. Especially when we just had about half an hour of debugging a data race condition. So your image in this thumbnail perfectly describes my feeling about the bug. We tried to analyze. Yeah, indeed, yeah. I agree. All right, this has to be on top here. I love it, Robin. Thank you very much. I'm gonna actually do one of the tricks that I love doing, which is just adding a stroke here to make it look a little bit more part of the image. And there you go. This is the thumbnail. I'm gonna change it right now. So export as yeah, I think that's fine. Thumbnail 2. And yeah, this is how I do my thumbnails for the videos, by the way. I just Photoshop everything, and that's why it looks so shit. So SappyDev, answering your question, I already do Rust at work anyway, so like I'm already in the field. And I do like it, to be honest. I mean, I rarely run into issues like the ones we've had in the stream, which is like, you know, just issues that the compiler can advise you on and avoid from letting you compile, basically. So yeah, we could do the same project in Rust as well in the future. I mean, I'm down to do that if you guys are actually interested. So we do have a memory leak somewhere, though. Look at this. Leak sanitizer has encountered a fatal error. So yeah. Anyway, what am I doing now? Right now I am switching the video details here. So we're gonna change this to something else. There you go. You're part of the video now, Robin. Thank you very much. It's midnight 37 here. I wish you all good night and sweet dreams. See you all guys around. I'll once again, dude, thank you very much for joining. And I didn't know you're in Germany, right? That should be that's fun. But anyway, man, thank you for joining, and thank you very much for helping debug the shit. So yes, please. I want to learn how to shift to Rust for graphics. Oh, for graphics, yeah. I mean, I think all the binaries, all the libraries I know for graphics in Rust are like just binaries from the C++ ones. But yeah, let's try this one now, Robin. Let's try another program by Robin, and let's download it, shall we? Don't save, and then we're not going to save it again. But what we're going to do is we're going to go into the virtual assembler. I'm going to replace. Is the color palette the same, dude? Let me know. Let's assemble it. Assemble it again just to make sure. And download the binary. Yeah, but it's scruffed. Let's see what that means. So Robin's code v2. And in here we're going to do the same thing. So copy. So move. I think your old palette would work better. Okay, we can try that. We'll try both. I mean, I still have the right palette on this, on here. What am I doing? This is what I'm looking for. I need to remove these logs, man. They're getting too much. I'm loving it, dude. Thank you very much. Problem is, this is like, I wish I had more pixels here. Maybe we can like extend the thing so it's not 32 by 32. But I love it. I love it. It's amazing. Thank you. Still, my old program doesn't work, but I guess I can just keep working on it, right? Let's try it. I want to make sure that we write every pixel drawing. We draw every pixel, one color each for every pixel in the screen. That's what I want. That's what I meant to say. So now I do have some stuff that's not supported still, and we can find that out real quick. I try my best even with my limited knowledge. Yeah, it's gruffed. Definitely have to do this mini project for myself. Yeah, Al, if you're still around, definitely worth trying. Sappy Dev, I think I missed your message. Sorry about that. Oh no, I didn't. Yeah. But we have here a no locked somewhere. Yeah, we're gonna just run this again and see whenever he reaches this branch, because that means it's a thing that we don't support. Yeah. And which one is it? I'm just getting really tired of like implementing different instructions. 208. So what's 208 again? 208 is, oh no, it should be in decimal. 208 in decimal is D0. D0 is D0 BNE. Yeah. It takes 2 bytes, you see here, and the opcode is D0. Let's apply that. So D0 should be somewhere after C, right? So D0 is going to go here. What am I doing? So K's 0x D0. This is branch not equals to. And I think what this does is actually, it just checks. Yeah, we do need a branch not equals to here. And then that's going to be the byte thread. And we're going to break. Right. Yeah, so I got to read on this particular instruction because I'm not entirely sure what it does, to be honest. I think it checks that the carry flag is in 0, so 65 or T branch not equals. Or again, we use ChatGPT, right? Because we can. So explain how branch of BNE works. Hello Matt, how is the emulator going? It's going good, Stefan. We can display some good images that our friend Robin has created for us. In fact, what you see on the thumbnail is what what Robin has done for us. So yeah, let me just show you actually really quickly, because I actually kind of like it. I love the first version a little bit better, Robin, if you may ask. So this is what we can run. I mean, this is only comprised of 2 instructions anyway, so it's not that difficult to run this one. But yeah, and it just draws that from a big kind of program, basically. And you know, our pixel art master Robin has also done a second version, which is also very cool, but a little bit like low res. This one. So yeah. Tutorial and what? You saw that? I don't know what you're referring to, my man. You're gonna have to be a bit more specific there. But yeah, anyway, so we we're now trying to emulate a slightly more complicated program, which is this one, which has jumps and stuff. Go back to the browser. But I am interested now. Like, what did I search here? I'm not gonna show it to you. Well, whatever. Good live, left a like. Thank you, dude. I definitely don't have that on my search bar. So, anyway. In 6502, and how it checks flags. I'm pretty sure it just checks the carry flag to make sure it's not set. V2 slaps more. Yeah. I mean, I disagree. V1 is the one for me, but. So the BNE instruction is 6502. It stands for branch if not equal. It's a condition branch that an instruction that allows the program to change the flow of the execution based on the state of the processor's status flag, specifically the 0 flag. Also checks the 0 flag. And before executing BNE instruction, the processor first checks the status flag. If the case of BNE, it checks the 0 flag is set. Branch condition. If the 0 flag is not set, the branch is taken. So if it's 0, the branch is taken. So if the 0 flag is not set, this means that the program will jump to a new memory address specified by the operand of the BNE. The operand is assigned 8-bit offset. Yeah. Branching, yeah, so this is 2's complement. I think I was referring to the 6502 Google tab, second link, and its tutorial on it. What the hell? Oh yeah, I mean, I'm guessing you guys aren't like native English speakers, right? Because aid kind of means something else as well, by the way. It means help in English. But I like the little joke though. It is nice. This is what aid means, by the way. So I guess the guy that particular link means the plural version of this, not the disease that you may be thinking of. But yeah. Anyway, so there's a little bit of complexity in implementing this instruction because we have to work out things in, as you can see here, in 2's complement, right? So what we do is basically just a reinterpret cast, I think. Yeah, I'm pretty sure this matches whatever is in C++. So let's see the possible values. C++ car or stud int 8t. Int 8t. So what do we have here? Int 8t min. What's the minimum value? Okay, it tells me it exists. It doesn't tell me what the minimum value is. I love it. Yeah, it's reinterpret cast of signed car, yeah. Well, in my case, it would be an int 8. But I just want to make sure it matches what we expect. Yeah, so, not too difficult. Is it pixel dry in the program? Yeah. Anyway, so let's actually do that. So we have emulator BNE. So bytes read is going to be BNE, and then we have the program here, which is the CPU, and then the program, I guess we're going to pass that to here. Now we have to create this. We have to create the function. We don't really have anything like it. So the compare instructions here, let's put the branching next to the one. Branching functions here. Yeah, so we have stud optional of a stud size t for us, which is going to return the size that bytes that we have just read. BNE, and then we have the emulator CPU here. CPU, and then we have the program itself. So it's stud spam const stud uint8t, program. Now, so at the end of the day, like what we want to do is like make sure that we can change the CPU dot registers. Or was it reg dot PC? It's going to be set into something, right? That's basically what we want to do. So the first thing we want to do is like, I guess, check that the CPU flags the flag 0 is set, and if the flag 0 is set, is that how it does it? Is that how we do it? So if the flag 0 is set, if the flag 0 is not set, the branch is taken. So if it's 0, right? So that's what we want to do. So if this is not set, we take the branch here. So we do CPU.reg .p, in this case PC, is going to be plus the offset. And that's what we're going to do here. And this offset is going to be calculated from, I guess, the other byte. So auto const offset, got a static cast to stud int 8t, which is going to be my CPU or my program at cpu.pc.regis.pc plus 1. And that's basically it, I think. That's it, right? I think that works. I'm not going to write a test for it. I know it doesn't work. I know it probably won't work. But yeah, we don't have anything here, so return 2. We need to return the size of bytes that we just read from the function. Now let's run the emulator again and see what the next function is to implement. So, command 197. So 197 is C5. I swear we've already implemented C5. Instruction set, we have C up here. The navigation for this is terrible. C5, right? So compare memory with accumulator. Ooh. So we've already got a comparison function here. So we have this C5 here, which is the 0-page comparison, which takes 2 bytes, 3 cycles, because it has to do an indirection. So this will reach whatever is in the memory and compare it to A. So it does A minus memory. So that's what we're going to implement here. So the 0-page operator. Oh gosh, I can't. Fuck sake. There you go. Where's our switch case? Let's implement that one. So operator is C5, 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 which will be here somewhere. C0, 0x, C5, and this is what we have. So compare yeah, so this was going to be bytes read, bytes read equals, I guess, compare 0-page register, and we're going to create that now. Passing the CPU program. Oh, Robin, you've got another one, dude. I'm excited for it. Emulator, registers, and then we have what? With A, right? That's what we want to compare it with. And we break out of this. And we want to implement this right here. I will post the original to you so you can see the real color palette after. I thought it was my Discord for a second. Oh, by the way, Stefan, if you're not part of the Discord, dude, make sure you join it. I'm always in there for any questions or any suggestions, so join our Discord, man. You always get to talk to like to people like Robin with the same interests and stuff. So anyway, so compare zero, we have emulator. I'm having to talk a little bit quiet now, guys, because I have a partner and she's asleep, so I do apologize if you can't hear myself very well. And we have emulators, registers. Compare zero page register, and this is basically going to be the same as this, right? Except we have an indirection somewhere. Ooh, there's a bunch of code that we can like basically split out and refactor. I've not started that bit yet. So we have the value. Okay, that's basically it. Just we have an extra level of indirection now. I think that should work, right? Because it gets the value as that, and then the flags are set in the same way. Yeah. I'm gonna build this, and then we're gonna run it. Hello, welcome to the Discord. Now let's run this and see what happens. Okay, so that kind of works. Problem is, we're just going and going, I think. We haven't stopped anywhere. Where are we? We have an infinite loop here, guys. We never reached this, right? Yeah, we never reached that. Oh, that's sad. Something must not have worked, unfortunately. Oh, did it? quite playing nicely. So we have storing into the accumulator, 255 to the accumulator. I'm not about to fix another issue on stream that's going to take hours, so I'm going to run your program, Robin, and then we'll call it a day, dude, because it's really late here and I need to go to bed. Right, so we have another file to compile. Assemble. Is it the same file? It can't be the same file, right? Alright, so now we download the binary. We have Robin's code v3 now. And yeah, let's run that. Let's run that. Maybe I'll do like another 10 minutes on the emulator. Maybe it's something we can quickly fix as well. I think is the branch function that's probably not working, if I'm honest. But yeah. Oh, that's amazing. Now give me... I like the mustache though. I think it captured me fairly well. That's really good, dude. Like, how'd you get all this art done? Are you like taking a screenshot and then putting it through I guess some sort of like AI that's doing this? Because you're doing it very quickly. But I love this. This one I did it myself right now. Oh, that's amazing. Dude, you're really talented. Like, if you can whip that out in like 2 seconds, that's ridiculous. That's amazing. Now the background should be cleared white, and I think that would work a little bit better, right, if I did that. So if instead... I mean, you must be setting it to black everywhere, right? Is that what you're doing? Let's see. Where is the file? Are you setting all the pixels to black first? Yeah, I mean, would be nice if you can set all these blacks on the background to white, and then you can have like a bigger distinction between my hair and the... I'm assuming that's me, right? I'm not sure. It could be you as well. Maybe you look like me. But I like the 8-bit version of myself. Like, this is really cool, dude. I love it. That is amazing. You've got another one now. Right, I thought that was Discord. I could help with pixel art too, since that's what I used to do back in the day. Shouldn't be too hard to convert it into a bin, right? That's the thing though, you're not just converting it to a bin, Stefan. You're converting it to a set of 6502 instructions that will write into the memory the image, so then the emulator can display it like you can see it here. So, you know, it's not just that. It's in a GIF version where you blink. That's amazing, man. That's incredible. But yeah, it was Discord. It was Discord. Wait, what? Oh shit, that's amazing, dude. This is amazing. How'd you do it so quick? Like, what software did you use, by the way? I'm quite interested now. This is ridiculously good. I'm gonna start paying you to do all the art on the channel, dude. I think you deserve it. Pixel. Alright. is like an open source kind of thing. So Pixel. This is really cool. Good pixel art program. Yeah, that's insane. I'm definitely gonna like keep this in the notepad somewhere. Right, back to this for a little bit because I think I'd really wanna try and fix this at least. So the B&E instruction that we've got here on the program should be going back. Let's see. So B&E, which was something like, bought it a long time ago. Is it expensive? So it's not free. I thought it was free. I mean, it's free for those who want it to be free, right? I guess. Do not commit piracy. B&E. Nah, like $10. Oh, that's very cheap actually. Really, really cheap. So I think something is wrong here. So if the bit flag is not set, so if it's set, if it's 0, that means this is going to be false. Could it be this? Yeah, so we're going to take a look at this the first time. It could be that just I've inverted the logic basically. And I like the program, so I thought I would support the creators. Yeah, indeed, yeah. That's very important. I mean, even back in the day when I used to kind of like download programs without paying for them, as soon as I like enjoy the program, I would obviously pay for it because you want to support the creators anyway. Right, so we've got B&E here. And the bit flag isn't set, so we jump. That's correct. So -9 is what we want to do. And out of interest, what is it? D0, right? So we're looking for a D0 in here somewhere. So branch not equals to decrement. So we're looking for a D0. So it, ooh, what is this? So if we do a hex dump, we're looking for E9. What is E9? It's 233 in decimal. E9 is 233. Where is PC in this case? 21. So looking at the 23rd value. So 197, is that correct? That's incorrect. This is not right. So offset is going to be whatever's in 21, it's going to be in 22. So PC is 22 in this case. This is drawing 1 pixel at a time, and I'm doing that 32 times, which is fairly annoying, I guess. So B&E. And this is, yeah, the offset is -23 now. So we're jumping from, we are jumping from here to here. It's -23. So we expect the next one to be an LDX, right? Yeah, so it is correct in that case. So why does it not draw me anything? This is annoying. It doesn't draw me anything. Maybe my store function isn't working fine. I mean, this is all we have though. Story 255 into the accumulator. This should never be 255s all the time. Replace the 8th color with the palette with this one. I will do in a second. In this case, I don't think that's the issue though. We have enough colors here. We're drawing like each one of them anyway, so. I think it's probably something that so storing 255 into the accumulator. Yeah, I was just thinking about the pixel art to make it look better. Ah, okay, yeah. Yeah, I'll do that in a second. Just give me 1 minute, let me try and like fix this first and then we'll run your pixel art again. So basically, this STA here is the one. So STA 0 page indirect. Absolutely no stress. Sorry, Robin. If I was rude, I didn't mean to sound rude. My bad. It's just like whenever I'm like doing something in the middle of something, and I get distracted, I always get it wrong in the end. So I find it very difficult for me to focus. I should probably get it tested. I probably do have something, but don't know about it. So this is the function that's loading, storing things indirectly. And I think this might be wrong. I think, not entirely sure. So we load that, and then the indirection is the PC plus 1, and the position actually comes from, oh, wait a second, so the indirection plus 1. Ah, okay, I'm only reading 1 byte. This is the issue. I'm only reading 1 byte here. So this should actually take the 2 bytes that are in this address here, whatever this indirection is, and interpret them as a word. And this is what I'm not doing here, basically. So reading this again here, what do we have? So B0 plus I. So we read whatever we have in B0 in this case. Let me just clear my head. So we have whatever we have. So auto const the address. So the word address, that's going to be equals to the program at cpu.reg. Yeah, I mean, it's just in direction, right? We just probably should change this to word position. Now, when we position 1, so this is the lowest bit, and then this is the highest bit. So least significant bit and the high significant bit. So we then auto, and then the actual position is going to be the high significant bit to 8 here plus LSB, right? All of this, and simply plus CPU.reg.y. And this guys is why this instruction here to load or to store STA, right? Is it STA? This is why this instruction here takes 6 cycles, because you can see the amount of work that the CPU is actually doing here. It's working out a lot of indirections. And then the position. Yeah, in this case we just need position here. Right, with a bit of luck, this works a little bit better now. So the program in itself did run. And now we have everything working, which means that we've achieved what I wanted to achieve today. It took a little bit long, but to run this program, which has a few more instructions in it and a few jumps, and it essentially just draws all the colors in the palette one by one, and it wraps around, right? Hey Arkonaf. Dude, you're still here, man. You're still here, dude. But thank you for sticking around. Guys, please like the video. We've achieved something in this video. Now, let's get back to Robin. Robin and his amazing pixel art. Let's run it. Right, so I need to change the color palette, right, Robin? You said change the 8th color here. We can do that, surely. The 8th color, so do you mean the 7th address? Or the 9th address? Which one? Or the 8th address? So 6, 7, 8. I think this here, right? This is the one. Yeah, okay. Well, let's run it again. Maybe it still looks goofy though. Oh yeah, this is not your program. It's my bad. So Robin's code v3. So I really appreciate. Oh no, it looks much better. It's less yellowy now. Maybe it still looks goofy though. No, this looks amazing. Robin, I'm gonna like post this on the Discord channel because you deserve it, dude. You deserve the recognition. It draws myself as pixel art. Thank you very much, Robin. That was amazing. So on the mustache is even better than its real counterpart. Yeah, my mustache in real life isn't that prominent, to be honest. In fact, my girlfriend demands that I shave it every time because I end up looking Mexican, I think. But yeah. Anyway, guys, I'm quite happy with today's stream. I think we've achieved quite a lot of things. I definitely loved the pixel art that Robin drew here for us. I think, you know, this is the best thing that's happened on the stream so far. And I'm gonna close it here, guys. It's been amazing. It did take us like it took us 4 hours to do everything, but we debugged some stuff. We realized that we can't just ignore the memory data race issues that we had, and most of all, I got to chat to some of you. I got to spend quality time with some of you, and I appreciate that very much. But yeah, until the next time, maybe I'll do a stream on Sunday if I'm not feeling too tired. Maybe Monday will be the next stream. But I appreciate you all very much, and have a good evening, and love to you all. Bye bye.